There is a place beyond all worldly noise, a silent theater where the oldest stories are told not in words, but in light. In this profound emptiness, an instrument of incredible precision now drifts, a solitary golden eye turned toward the dawn of time itself. It was designed with a singular, audacious purpose: to capture the faint, ancient photons that have journeyed for billions of years across the expanding void. Each particle of light is a messenger, a fragile ghost carrying a secret from a universe that was young and wild and new. The James Webb Space Telescope waits in the cold, patiently collecting these messengers, translating their spectral whispers into a language we can begin to comprehend. Its mirrors, a honeycomb of gold and beryllium, form a perfect surface to gather the echoes of creation from the very edge of seeing. Recently, this magnificent eye focused its gaze upon a patch of sky that appeared to be an unremarkable, quiet corner of the cosmos. For hundreds of hours, it stared into the darkness between the stars, allowing the faintest signatures of light to accumulate on its sensitive instruments. The data was then streamed across the immense distance back to Earth, a silent cascade of numbers holding an undiscovered country within its code. And when the image was finally assembled, when the numbers were transformed into color and form, a hush fell over the halls of science. The astronomers who had waited for this moment, who had dedicated their lives to such a pursuit, found themselves without the adequate words to respond. What they saw was not just another beautiful photograph of the heavens, it was a fundamental challenge to our models of the universe. It was a window into a time and a place that, according to our best theories, simply should not have existed in the way it appeared. This is the story of that image, and the profound, humbling silence it has cast over our understanding of everything we thought we knew. Let us begin our journey not with the image itself, but with the concept of looking back in time, which is the telescope's true function. The light from our own sun takes 8 minutes to reach us, meaning we always see it as it was 8 minutes in the past. The light from the nearest star system, Alpha Centauri, takes more than 4 years to cross the interstellar gulf that separates us. Webb is not designed to look at our neighbors. It is built to see the light from the very first galaxies to ever form. The light from these primordial structures has been traveling for over 13 billion years, a journey that began when the universe was an infant. To see this light is to witness the cosmic dawn, the moment the first fires were lit in the incomprehensible darkness after the Big Bang. This is what astronomers were searching for in that silent patch of sky, the faint, stretched, and reddened light of the beginning. The expansion of the universe itself stretches the wavelength of this light, shifting it from visible light into the infrared spectrum. The Webb telescope is an infrared instrument precisely for this reason, allowing it to perceive this ancient, time-worn light that is invisible to our eyes. And so it stared, and it gathered, and it waited for the ghosts of the past to give up their form on its golden mirrors. The target was a region known as a stellar nursery, a vast cloud of gas and dust where new stars are expected to be born. These nurseries are typically chaotic, beautiful messes of collapsing gas, radiation, and the raw material of future solar systems. But within this particular cloud, Webb focused on a single point of light, a protostar just beginning to ignite and shape its environment. It is here, in the swirling disk of matter around this embryonic star, that the speechless moment truly began to take shape. The expectation was to see a familiar pattern, a disk of gas and dust slowly coalescing, the first steps of planetary formation. What the image revealed was something else entirely, something so unexpected it sent ripples of shock and awe through the astronomical community. Instead of a simple uniform disk of primordial material, the telescope saw structure, complexity, and a level of order that was breathtaking. There were clear, concentric rings and gaps in the disk, almost like the grooves on a vinyl record, etched into the cosmic dust. Such gaps are usually the telltale sign that planets have already formed, sweeping their orbits clean of debris like cosmic plows. But this star system was far too young for planets of that size to have taken shape according to all our current theories of planet formation. It was like looking at a photograph of a 2-week-old infant who was already walking and talking and writing poetry. The timeline was wrong. The image showed a level of maturity that should have taken hundreds of millions of years longer to achieve. This was the first reason for the silence. The image presented a deep and profound paradox that defied our established timelines of cosmic evolution. But the telescope's work was not done, for it is more than just a camera. It is a laboratory for starlight itself. Using its spectrographic instruments, astronomers could analyze the chemical composition of the gas within those mysterious ordered rings. They were searching for the simple elements: hydrogen, helium, the basic building blocks you would expect in such a young, pristine environment. And while those elements were present, the spectrograph revealed something else: a series of chemical signatures that were both shocking and electrifying. Floating in the gas of this impossibly young solar system were the clear, unambiguous signatures of complex organic molecules. Not just simple methane, but more complex structures like polycyclic aromatic hydrocarbons, the very same compounds found in oil and coal on Earth. These are the chemical precursors to amino acids, the fundamental building blocks of proteins, the machinery of life as we know it. To find them here in such abundance in a system so young was the second and perhaps greater reason for the stunned silence. It suggested that the raw ingredients for life are not a rare or late-stage development in the universe's history. Instead, it hinted that the cosmos might be seeded with these life-giving compounds from the very beginning. The universe, it seems, is not just waiting to create life. It appears to be in a great hurry to do so. The image was a 1-2 punch to our cosmic assumptions, accelerated planetary formation, and the widespread presence of prebiotic chemistry. This is the portrait that left astronomers speechless, a quiet revolution delivered in a single, breathtaking frame of ancient light from afar. Let us now delve deeper into the first astonishing revelation: the structure of the protoplanetary disk itself. The established model, known as the core accretion model, is a slow, stately, and rather methodical process. It posits that for a planet to form, tiny dust grains in the disk around a young star must first stick together through electrostatic forces, like dust bunnies under a bed. These grow into pebbles, then into mile-wide planetesimals, which then collide and merge over millions of years to form planetary embryos or cores. Only when a core reaches a critical mass, perhaps 10 times that of Earth, does it have enough gravity to rapidly pull in vast amounts of gas from the surrounding disk to become a gas giant like Jupiter. This entire sequence is thought to take at least several million, if not tens of millions of years. The Webb image, however, showed distinct clean gaps in a disk around a star estimated to be no more than 1 million years old. This is cosmically instantaneous, and it presents a profound timing problem. It's like finding a completed skyscraper on a construction site where the foundation was only poured yesterday. This temporal paradox forces us to consider more radical and rapid theories of planet formation. One such idea is known as the gravitational instability model. In this scenario, planets are not built slowly from the bottom up, but rather form quickly from the top down. If a protoplanetary disk is sufficiently massive and cold, it can become gravitationally unstable. Instead of a smooth, rotating sheet of gas and dust, the disk can fragment under its own gravity, with large regions collapsing directly and rapidly into dense clumps. These clumps, which can be the mass of Jupiter or even larger, would form in as little as a few thousand years, a mere blink of a cosmic eye. These newly formed protoplanets would then carve out the observed gaps in the disk almost immediately. The Webb image, with its startlingly mature architecture, provides the most compelling observational evidence to date that this more violent, accelerated process might not be the exception, but perhaps a common or even dominant mode of planet formation in the universe. It suggests a cosmos that builds its worlds not with painstaking patience, but in spectacular, rapid bursts of creation. The clarity of the gaps in the disk is another source of profound wonder. In many previously observed protoplanetary disks, the edges of such gaps are fuzzy and ill-defined, suggesting a gradual clearing process. But in this new image, the divisions between the rings are sharp, almost as if they were carved by a precision instrument. This implies the presence of very massive bodies whose gravitational influence is overwhelmingly dominant in their orbital zones. These are not merely forming planets. They are young giants already acting as the powerful architects of their nascent solar system. They are shepherding dust and gas into defined rings, creating a celestial architecture of immense order and scale. The image transforms our view of these disks from chaotic, dusty messes into something more akin to a grand cosmic orrery, a set of nested, moving structures all governed by the gravitational pull of unseen, newly born worlds. It is a portrait of order emerging from chaos with breathtaking speed and elegance. Now, let us turn to the second, and arguably more profound, discovery hidden within the light: the spectrographic analysis. Spectroscopy is the art of breaking light down into its constituent colors, creating a rainbow or spectrum. When light from a star passes through a cloud of gas, atoms and molecules in that gas absorb light at very specific frequencies, leaving dark lines in the spectrum, like a barcode. Each molecule has a unique spectral barcode, allowing astronomers to identify the chemical composition of objects billions of light-years away. It is through this remarkable technique that Webb analyzed the gas swirling within the rings of the protoplanetary disk. The instrument was not just seeing the structure, it was reading the ingredients list for a new solar system, and the results were paradigm-shifting. The detection of polycyclic aromatic hydrocarbons, or PAHs, was the key. Polycyclic aromatic hydrocarbons are not simple molecules. They are complex, ring-shaped structures of carbon and hydrogen atoms, the kind of organic soot you might find in engine exhaust or from a charcoal grill. On Earth, they are formed from the incomplete combustion of carbon-containing materials. To find them in the cold, thin environment of a protoplanetary disk is not, in itself, unprecedented. They have been detected in interstellar space before. However, the sheer abundance and location were what stunned the observers. They were not just diffusely spread throughout the cloud. They were concentrated within the inner regions of the disk, the very zone where terrestrial, rocky planets are expected to form. This means that the raw materials for complex organic chemistry were not just available, but were being delivered directly to the construction site of future Earth-like worlds at the earliest possible stage of their development. It is a cosmic delivery service of the most vital ingredients. This discovery fundamentally reframes the question of the origin of life. For decades, the debate has centered on whether life's building blocks formed on Earth itself, in a primordial soup energized by lightning or volcanic vents, or if they were delivered to a young Earth by comets and asteroids from elsewhere in the solar system, a theory known as panspermia. The Webb image suggests a third, more encompassing possibility: that the entire solar system, from its very inception, was born from a nebula already richly seeded with the necessary organic precursors. The building blocks of life weren't an afterthought or a lucky delivery. They were part of the foundational material. The planets, asteroids, and comets all formed from the same enriched cloud. This implies that any rocky planet forming in that habitable zone would have, by default, incorporated these complex molecules into its very fabric as it formed. The potential for life, therefore, may be baked into planets from day one. Consider the implications of these two discoveries in tandem. On one hand, the gravitational instability model suggests that large gas giants can form very quickly in the outer regions of a solar system. These giants are not just celestial bodies, they are gravitational shepherds. Their immense pull can perturb the orbits of smaller bodies like comets and asteroids, flinging them towards the inner solar system. On the other hand, the spectrographic data shows that the entire disk is rich with the complex organic molecules necessary for life. So you have a scenario where the universe is not only providing the raw ingredients for life in abundance, but it is also simultaneously and rapidly creating the very planetary architecture, the giant outer planets, that can efficiently deliver those ingredients via comets and asteroids to the inner, rocky worlds where life might take hold. It's a self-contained, two-part system for kickstarting biology on a galactic scale, and it is happening far faster than we ever imagined. The silence of the astronomers was not one of confusion, but of reverence. It was the silence that follows the final chord of a magnificent symphony, when the sheer beauty and complexity of the composition leaves you momentarily unable to process what you have just experienced. The image held up a mirror to our theories, and the reflection was of a universe that is far more efficient, more elegant, and perhaps more purposeful in its drive towards complexity than our previous models had allowed. It challenges the Copernican principle that we are nothing special. While we may not be at the physical center of the universe, this image suggests that the conditions for life, the very ingredients and processes that led to our existence, might be so profoundly common and rapid that they are a standard feature of cosmic evolution not a rare exception. This finding forces us to re-evaluate what we look for when we search for extraterrestrial life. Perhaps we have been too conservative, focusing only on older, stable, sun-like stars. The Webb image suggests that the action might happen much earlier. The most potent moments of creation, both planetary and possibly biological, could be occurring within the chaotic, shrouded maelstroms of the youngest stellar nurseries. It tells us that the seeds of life might be sown long before a star even settles into its main sequence of adulthood. The search for life may need to shift its focus to the cradles of the cosmos, to these impossibly young systems where the universe is writing its story of creation at a furious, breathtaking pace. We may have been looking for life in quiet suburbs, when all along it was flourishing in the heart of bustling, nascent cosmic cities. The implications extend beyond just biology and planetary science. They touch upon our cosmic timeline. The universe is approximately 13.8 billion years old. Our solar system formed around 4.6 billion years ago, meaning the universe was already over 9 billion years old when the Earth was born. If planetary systems and their organic building blocks can form this quickly, as the Webb image suggests, then the first generations of habitable, life-bearing planets could have formed much, much earlier in cosmic history. Potentially, life could have emerged in the universe when it was only 2 or 3 billion years old. This opens up an immense, previously unimagined expanse of cosmic time in which life could have arisen, evolved, and perhaps developed intelligence and technology. We might be latecomers to a cosmic story that has been unfolding for 10 billion years before our sun even ignited. This vast temporal landscape is both exhilarating and deeply humbling. It provides a potential solution to the Fermi paradox, the question of where is everybody? Perhaps ancient civilizations are not zipping between the stars in physical ships, but have evolved beyond such things. Or perhaps they existed and faded billions of years ago, leaving behind only echoes that we are not yet advanced enough to detect. The Webb image suggests the conditions for life are not the bottleneck. The bottleneck may lie elsewhere, in the transition from simple life to complex life, from intelligence to technological societies, or in the sheer longevity of such civilizations against the backdrop of cosmic timescales. The universe may have been teeming with nascent life for eons, a garden of countless potential worlds, where the story of life has played out 1 billion times over, long before our own chapter began. Let us contemplate the nature of the light itself that brought us this message. It is infrared light, which we perceive as heat. The telescope is, in essence, seeing the warmth of creation. It is peering through the cold, dark clouds of interstellar space that would block visible light, and it is sensing the faint, residual heat of these primordial processes. There is a deep poetry in this. The very processes that create the potential for warm, living beings are revealed to us through the detection of their faint, ancient warmth, a thermal echo crossing billions of years. The universe, it seems, communicates its most profound secrets not through brilliant, dazzling displays, but through the quietest, most subtle and gentlest of whispers, a warmth in the dark that tells a story of furious and rapid creation. The image also serves as a testament to human ingenuity and our unyielding curiosity. The James Webb Space Telescope is one of the most complex machines ever built, a triumph of engineering and international collaboration. It was assembled on Earth, folded like a piece of intricate origami to fit into a rocket, launched into space, and then meticulously unfolded itself 1 million miles from home. Its sunshield, the size of a tennis court, deployed flawlessly. Its 18 hexagonal mirrors aligned themselves with a precision smaller than a virus. All of this was done to capture a handful of ancient photons, to answer the most fundamental questions we can ask. The speechless awe of the astronomers is not just for the universe's revelation, but also a quiet, profound pride in the magnificent instrument that humanity created to receive that revelation. It is a dialogue between the cosmos and its curious children. The discovery challenges the very notion of waste in the cosmos. We look at the vast, empty spaces between stars and the billions of galaxies and see so much unused potential, but this image reframes our perspective. The complex organic molecules detected are forged in the hearts of dying stars and then cast out into the interstellar medium in supernova explosions. This material then enriches the gas clouds that will form the next generation of stars and planets. Nothing is wasted. The death of a star is the planting of a garden for the next. The universe is a grand, cyclical system of recycling, where the ashes of one generation become the building blocks of the next. The PAHs in this distant young disk are the recycled remnants of long-dead stars, now being incorporated into new worlds, a cosmic inheritance passed down through the eons. One of the most beautiful aspects of this image is what it does to our imagination. It gives us permission to speculate with a firmer grounding. Before, the idea of a galaxy teeming with life felt like hopeful fiction. Now the evidence suggests that the potential for life is a fundamental, baked-in property of cosmic matter. We can now imagine with more confidence the countless worlds forming in those primordial clouds, each one seeded from the start with the chemistry of life. We can imagine the diverse environments, the different paths evolution might take on worlds orbiting stars of different colors and sizes. The image doesn't give us answers about alien life, but it enriches the question, making it more real, more plausible, and more profound. It turns a philosophical question into a scientific inevitability that we are now equipped to investigate. Let us return to the structure of the rings and gaps. The precision of these features hints at a phenomenon known as orbital resonance. This occurs when two or more orbiting bodies exert a regular, periodic gravitational influence on each other, often stabilizing their orbits. Our own solar system has examples, such as the resonance between Jupiter's moons or between Neptune and Pluto. To see such ordered, resonant patterns in a system so young suggests that the fundamental physics of stability and order assert themselves incredibly quickly. It is not a long, chaotic process of settling down. Instead, solar systems may self-organize into a state of dynamic, mathematical harmony almost as soon as they are born. The universe, it seems, has an inherent preference for elegance and order, writing its laws not just in matter, but in the gravitational music of the spheres, from the very first moments of planetary formation. The presence of complex molecules also has implications for the habitable zone concept. This is traditionally defined as the region around a star where liquid water could exist on a planet's surface. But this discovery suggests that a biochemical potential zone might be a more fundamental concept. The raw materials for life are not just a nice-to-have extra, they are a key ingredient. A planet could be in the perfect location for liquid water, but if it formed from a sterile cloud devoid of complex organics, it might remain a dead world. This image suggests that the biochemical potential zone and the habitable zone may be one and the same, that the very material which forms planets in that temperate region is already preloaded with the necessary ingredients. It connects the chemistry of life directly to the real estate where it could flourish. This is a deeply optimistic discovery. In a universe that can often seem cold, violent, and indifferent, this image provides a counter-narrative. It portrays a cosmos that is fertile, creative, and in a hurry to set the stage for life. It shifts the cosmic narrative from one of bleak, improbable chances to one of abundant potential. The silence of the astronomers was the sound of a paradigm shifting, the quiet intake of breath before a new chapter of exploration begins. It was the feeling of standing on the shore of a vast, newly discovered ocean, knowing that the maps must all be redrawn and that the journey ahead is far grander and more mysterious than previously imagined. The universe is not a barren desert with a few scattered oases. It may be a lush, sprawling garden, and we have just been given our first glimpse over the wall. Let's consider the star at the center of this remarkable system. It's a protostar, not yet a fully fledged sun. It is still gathering mass from the surrounding nebula, a seething, turbulent ball of gas on the verge of sustained nuclear fusion. The environment around it is violent, bathed in intense radiation and powerful stellar winds. For a long time, it was thought that such a hostile environment would be destructive to complex molecules, breaking them down into simpler components. The fact that these PAHs and other organic precursors can survive and even be concentrated in such a dynamic and energetic setting is a testament to their resilience. It suggests that the very processes of star birth, which we viewed as potentially sterilizing, are instead an integral part of concentrating and organizing the building blocks for the planets that will eventually orbit the mature star. Creation and chemistry are not in conflict. They are partners in a cosmic dance. The image can be understood as a form of cosmic archaeology. Just as an archaeologist excavates layers of Earth to understand a past civilization, astronomers use telescopes to look back through layers of time and space. Each layer of redshift, each more distant galaxy, is an older stratum of cosmic history. The James Webb Telescope is the ultimate archaeological tool, capable of digging down to the very foundational layers of cosmic structure. What this dig has revealed is that the artifacts of life, the complex organic molecules, are not found only in the recent upper layers. They are present in the deepest, most ancient strata we can currently perceive. It is like finding the blueprints for a cathedral buried in the cornerstone of the city's oldest hut. It implies foresight, or at least a profound pre-configuration, in the cosmic architecture. The sheer speed of the process has profound implications for the search for intelligence. A common assumption in SETI has been that life, especially intelligent life, requires a long period of planetary and stellar stability. We have sought it around quiet, middle-aged stars like our Sun, but if solar systems can form and stabilize in a fraction of the time, and if the ingredients for life are present from the start, then the window for life to emerge and evolve is thrown wide open. Intelligence could potentially arise in systems that are, by our current standards, shockingly young. This forces a recalibration of our search strategies, perhaps pointing our radio telescopes not just at the quiet stars, but at the regions surrounding younger, more active stars, where civilizations might have had a cosmic head start we never thought possible. We must also consider what this image doesn't show. It shows us potential, not proof. It reveals a stage set for life, complete with props and scenery, but it doesn't show the actors. The transition from complex prebiotic chemistry to actual, replicating life is a gap in our knowledge so profound it is often called the hard problem of abiogenesis. While the Webb image tells us that the universe is incredibly efficient at providing the necessary ingredients, it does not tell us how to bake the cake. That mystery remains, perhaps the greatest in all of science. But by showing us how common and readily available the ingredients are, it makes the problem feel less like a miraculous fluke and more like a puzzle that has a solution, a chemical and physical process that we might one day understand and perhaps even replicate. The concentric rings in the disk, so perfectly formed, also invite comparison to phenomena of resonance and frequency at a quantum level. Just as electrons in an atom can only occupy specific, quantized energy levels, perhaps matter in a protoplanetary disk is encouraged by gravitational and hydrodynamic forces to settle into specific, stable, resonant orbits. It's a macroscopic echo of a microscopic rule. The universe exhibits a strange consistency in its laws, from the smallest scales to the largest. The beauty of the Webb image is partly this reflection of a deep, underlying mathematical order. It is a visual representation of physical laws playing out on a canvas of gas and dust, creating a pattern that is both scientifically informative and aesthetically breathtaking. It is where physics becomes art. This new understanding of rapid planet formation might also help explain the diversity of exoplanetary systems we have discovered. We have found hot Jupiters orbiting incredibly close to their stars and super-Earths in orbits smaller than Mercury's. The slow, methodical core accretion model has struggled to explain some of these exotic configurations. A more rapid, chaotic formation process, like gravitational instability, allows for more dramatic and varied initial conditions. It allows for massive planets to form quickly and then migrate inward or outward, scattering other smaller bodies as they go. The Webb image of this young, structured system could be a snapshot of the very process that leads to the wild diversity of solar systems we see throughout our galaxy. We are witnessing the birth of an architecture that could be wildly different from our own. Ultimately, the feeling of being left speechless is a deeply human response to confronting the sublime. It is the feeling that occurs when our intellect and our emotions are simultaneously overwhelmed by a scale or complexity that defies our everyday experience. The Grand Canyon, a powerful symphony, a stormy sea, these can all evoke a similar feeling. The Webb image is a work of cosmic sublimity. It presents us with a vision of creation that is too vast, too ancient, and too complex for our minds to easily contain. The silence is a moment of cognitive and emotional surrender, an admission of our smallness in the face of such grandeur. But it is a joyful surrender, one that replaces our old, smaller certainties with a new, more expansive and more profound sense of wonder. Let us contemplate the journey of a single carbon atom, forged in the nuclear furnace of a star that lived and died billions of years before our sun existed. It was violently expelled into the interstellar void in a supernova. For eons it drifted through the cold darkness, part of a vast, diffuse cloud of gas and dust. Then, gravity began to pull that cloud together, and our atom found itself part of a swirling, condensing nebula. It bonded with hydrogen atoms, also ancient, to become part of a complex PAH molecule. This molecule, along with countless others, was incorporated into the protoplanetary disk shown in the Webb image. It now swirls in one of the defined rings, awaiting its destiny, perhaps to be integrated into a new planet, a comet, or an asteroid. This single image captures a snapshot of this atom's incredible, universe-spanning journey, from one star's heart to the cradle of a new world. The precision of the James Webb Telescope's instruments is difficult to overstate. To perform its spectroscopic analysis, it uses a microshutter array, a grid of 250,000 tiny windows, each smaller than a human hair, that can be opened or closed individually. This allows the telescope to block out the light from bright foreground stars and isolate the faint, almost imperceptible light from a single distant object within the image. It is this technological marvel that allowed astronomers to parse the chemical composition of the gas in that young disk with such certainty. It is an act of supreme technological focus, blocking out the noise of the universe to listen to a single faint whisper from the dawn of time. The speechless moment was earned through decades of such meticulous, painstaking innovation. This discovery also reshapes our perception of cosmic dust. We tend to think of dust as a nuisance, something that obscures our view. Indeed, interstellar dust clouds have long been a frustration for astronomers, blocking visible light from distant objects. But the Webb telescope, by seeing in infrared, pierces through this veil. And in doing so, it has revealed that the dust is not a curtain, but the stage itself. The dust grains are the very seeds of planets. They are the surfaces upon which simple molecules can meet, interact, and form more complex structures. The dust is a chemical factory and a construction site. This image transforms dust from a passive obscuring agent into the active, essential medium for the creation of worlds and the chemistry of life. The universe, it turns out, builds its most magnificent creations from the humblest of materials. The implications for the color of the universe are also fascinating. When we think of space, we think of the visible spectrum, but the most crucial events, the formation of the first stars, the assembly of the first galaxies, the creation of planets and dusty nurseries, happen largely in the infrared. The universe's creative processes are mostly invisible to our eyes. The Webb telescope is our first true set of eyes for this invisible, infrared cosmos. It is showing us that the universe's story is written in a language of light we are only just beginning to learn to read. The colors in the final processed image are representative. They are a translation of different infrared frequencies into a visible palette. They are a bridge between the universe as it truly is and the world as our senses can perceive it, an act of translation that brings us face to face with the unseen mechanics of creation. The silence that fell upon the astronomers is a crucial part of the scientific process. Science is not just about data and equations. It is about the human experience of discovery. That moment of awe, of being rendered speechless, is often the very catalyst for the next great leap in understanding. It is in that silent space that the old assumptions crumble, and the mind becomes open to new, radical possibilities. It is the pause where a dozen new questions are born for every one that has been answered. This image did not end a conversation. It started 1,000 new ones. Its legacy will not just be the data it provided, but the generation of scientists. It will inspire to ask bolder questions and to dream of even more audacious instruments to answer them. Consider the cosmic real estate. For a planet to be habitable, it needs heavy elements: carbon, oxygen, iron, which are only created in stars. The very early universe was almost exclusively hydrogen and helium. It took time for the first stars to live, die, and enrich the cosmos with these heavier elements. There's a sweet spot in cosmic history, a time after enough heavy elements have been created, but before the universe's expansion has diluted everything too much. For a long time, we assumed we were in that sweet spot now. This Webb image, showing such rapid and complex formation, suggests that the sweet spot may have begun much earlier and may last much longer than we thought. It expands the potential window for life's existence across both space and, crucially, across time, making the universe a far more welcoming place for a far longer period. The elegance of the ring structures is not just aesthetically pleasing, it is a clue about the fundamental forces at play. The gaps are likely cleared by the gravity of forming planets, but the crispness of the rings suggests other forces are involved. The radiation pressure from the central protostar can push smaller dust grains outward, while the stellar wind can also sculpt the material. Furthermore, magnetic fields, threading through the disk, can channel ionized gas and influence where material accumulates. The image we see is the result of a complex interplay between gravity, radiation, stellar winds, and magnetism. It is a masterpiece of cosmic physics, a dynamic equilibrium of competing forces that results in this stunningly ordered structure. We are not just seeing a snapshot. We are seeing the visible evidence of a host of invisible, powerful forces working in concert. Let's re-examine the term speechless. It does not mean thoughtless. In fact, it describes a state of mind so full of new thoughts, so overwhelmed by incoming data and its implications, that the language processing part of the brain cannot keep up. It is a cognitive overload of the most wonderful kind. The astronomers were not empty-headed. Their minds were racing, connecting this image to theories of stellar evolution, planetary dynamics, organic chemistry, and cosmology all at once. The silence was the sound of 1,000 mental gears turning, of a whole field of science reorienting itself in real time. It was the quiet hum of a collective paradigm shift, the moment before a flood of new papers, theories, and debates would be unleashed upon the world. This finding has a subtle philosophical resonance with the ancient idea of as above, so below. The same carbon that forms the basis of life on Earth, that makes up our bodies, is seen here in abundance at the birth of a new solar system. The same physical laws of gravity and resonance that shape our own solar system are seen carving out these distant rings. It reinforces the idea that we are not separate from the universe, looking in from the outside. We are a product of it, made of its recycled stardust and governed by its universal laws. The image is a family portrait. It shows us the very same kind of cosmic nursery from which our own sun and planets emerged 4.6 billion years ago. In looking out, we are, in a very real sense, looking back at our own origins. One of the most humbling aspects of the discovery is the location. This was not a famous, well-studied object. It was a seemingly unremarkable patch of a nearby star-forming region. It implies that these incredible phenomena are not rare cosmic jewels, but are likely commonplace. If this is what is happening in our own galactic backyard, in a nursery we can study in high detail, it stands to reason that countless other stellar nurseries, throughout our galaxy and in the billions of other galaxies, are undergoing the same rapid, life-enriching processes. The universe's creative potential is not a rare, localized event. It is a widespread, continuous, and standard operating procedure. We were not speechless because we found the one special place. We were speechless because we realized that everywhere might be this special. The discovery underscores the importance of patience in scientific endeavor. The James Webb Space Telescope was first proposed in the 1990s. It took more than 2 decades of design, construction, testing, and countless setbacks to bring it to fruition. Thousands of scientists and engineers dedicated large portions of their careers to this single project. The data it is now producing is the culmination of that immense, multi-generational effort. The overnight discovery that left astronomers speechless was, in reality, the product of a quarter-century of focused, unwavering human dedication. It is a powerful reminder that the greatest revelations do not come from sudden flashes of inspiration alone, but from the slow, steady, and collective pursuit of knowledge across decades. The presence of complex organic molecules so early in a system's life might also change how we think about the evolution of planetary atmospheres. It's possible that these compounds are integrated into the primary atmospheres of newly forming planets. As the planet cools and evolves, this organic-rich atmosphere could rain down upon the surface, creating vast reservoirs of the building blocks of life in oceans or on land. This is a much more efficient delivery mechanism than relying solely on later bombardment by comets and asteroids. It suggests that a planet's potential for life is not just a surface condition, but something that is deeply integrated into its entire atmospheric and geological system from the very beginning. The potential for biology could be a truly planetary-scale phenomenon from day one. This single image from Webb acts as a powerful rebuttal to cosmic loneliness. The idea that we are alone in the universe has been a source of both existential pride and deep-seated fear throughout human history. This evidence does not prove we are not alone, but it powerfully realigns the probabilities. It demonstrates that the universe is systematically setting the table for life in countless locations and has been doing so for billions of years. It makes the notion of a sterile, empty cosmos seem far less likely. It replaces the fear of loneliness with a sense of profound connection, a feeling that we are part of a vast, ongoing, and potentially universal creative process. We may not have met the neighbors yet, but we have seen that the neighborhood is full of houses built with the same life-giving materials as our own. We should also contemplate the fragility of the light that brought us this message. The photons captured by Webb began their journey over 13 billion years ago. They traveled through intergalactic space, dodged gravitational fields, passed through clouds of dust, and finally, in the last fraction of a second of their long existence, they ended their journey by striking a gold-plated mirror a million miles from Earth. The amount of energy collected is infinitesimally small. The telescope is detecting a level of energy equivalent to a bumblebee landing on the moon, as seen from Earth. The fact that we can build a machine sensitive enough to capture and decipher such an impossibly faint and ancient signal is, in itself, a source of profound awe. It is the ultimate testament to our ability to hear the faintest whispers of the cosmos. The speechless moment can be seen as a form of intellectual recalibration. Our brains are hardwired by evolution to understand the world on a human scale: meters, seconds, kilograms. Cosmology and astrophysics force us to confront scales that are alien to our intuition: light years, eons, solar masses. Our models and theories are our best attempt to bridge this gap. When an observation like this one comes along, it shatters our carefully constructed conceptual bridges. The moment of silence is the moment the brain acknowledges the failure of the old model and begins the difficult, exhilarating process of building a new, larger, more robust one. It is the feeling of our mental universe expanding to try and catch up with the physical one. The beauty of the image is not incidental, it is integral to its power. The vibrant colors, the elegant curves of the rings, the delicate structures within the gas, they speak to us on an emotional and aesthetic level. This is important, because it allows these profound scientific concepts to be accessible to everyone, not just specialists. You do not need to understand the intricacies of gravitational instability or spectroscopy to be moved by the image. The beauty is a gateway to the science. It invites us in, sparks our curiosity, and makes us want to understand the deeper meaning behind the breathtaking facade. In this way, the image serves as a great unifier, connecting humanity to the cosmos through the shared, universal language of awe and wonder. Let's consider the future discoveries this image now promises. This is just one of the first deep observations from a telescope designed to operate for 20 years or more. This is the opening sentence of a new encyclopedia of the cosmos. If such a profound discovery can be made in a seemingly ordinary stellar nursery, what will we find when we point Webb at the most exotic and mysterious objects we know of? What will we see when we look at the atmospheres of nearby exoplanets, at the center of our own galaxy, or at the most distant ancient quasars? This image is both a destination and a signpost. It is a stunning revelation in its own right, and it points the way toward an era of discovery that will likely reshape our understanding of the universe in ways we cannot yet even begin to imagine. The silence is just the beginning. This discovery also subtly alters our relationship with time. We often perceive the deep past as something static and gone forever. But this image reminds us that the past is an active, ongoing phenomenon. Because of the finite speed of light, the history of the universe is not just a story in a book. It is a visible, observable landscape. We can literally see the past unfolding before our eyes. The ancient light from this protostellar nursery is arriving at Earth right now. The telescope allows us to be present at an event that took place billions of years ago. It collapses the immense distance of time and space, making us direct witnesses to cosmic creation. We are not just looking at a picture of the past, we are receiving the past. a continuous stream of history flowing over us at the speed of light. The concentric rings are a powerful symbol of potential. Each ring is a zone of possibility, a potential future orbit for a new world. The gaps are not empty spaces, but declarations of presence, the unseen domain of a newly formed planet. The inner rings, rich with organic molecules, are the cradles of potential biology. The entire system is a nested set of promises. It is a blueprint not yet fully realized, a sketch of a solar system in the process of becoming. In a universe where entropy and decay are a fundamental law, where things tend to fall apart, this image is a powerful portrait of the opposite force, the drive towards assembly, complexity, and order. It is a vision of cosmogenesis, the universe's relentless and beautiful impulse to build. Finally, let us sit with the silence itself. In our modern world, we are surrounded by constant noise, information, and distraction. The experience of genuine, profound silence is rare and often uncomfortable. But the silence of the astronomers was not empty. It was full. It was filled with the weight of a new truth. It was a meditative state, a moment of pure observation without the need for immediate interpretation or commentary. In a way, the telescope invites us to share in this state. To look at its images is to participate in a form of cosmic meditation, to quiet our own internal noise and simply be present with the majesty of what is. The image is an invitation to be still, to look up, and to be for a moment wonderfully and completely speechless. The concentric rings in the disk are a powerful symbol of potential. Each ring is a zone of possibility, a potential future orbit for a new world. The gaps are not empty spaces, but declarations of presence, the unseen domain of a newly formed planet. The inner rings, rich with organic molecules, are the cradles of potential biology. The entire system is a nested set of promises. It is a blueprint not yet fully realized, a sketch of a solar system in the process of becoming. In a universe where entropy and decay are a fundamental law, where things tend to fall apart, this image is a powerful portrait of the opposite force, the drive towards assembly, complexity, and order. It is a vision of cosmogenesis, the universe's relentless and beautiful impulse to build. We should also contemplate the fragility of the light that brought us this message. The photons captured by Webb began their journey across thousands of light years. They traveled through interstellar space, dodged gravitational fields, passed through clouds of dust, and finally, in the last fraction of a second of their long existence, they ended their journey by striking a gold-plated mirror 1,000,000 miles from Earth. The amount of energy collected is infinitesimally small. The telescope is detecting a level of energy equivalent to a single photon from a candle flame 1,000 miles away. The fact that we can build a machine sensitive enough to capture and decipher such an impossibly faint and ancient signal is, in itself, a source of profound awe. It is the ultimate testament to our ability to hear the faintest whispers of the cosmos. Let us consider the future discoveries this image now promises. This is just one of the first deep observations from a telescope designed to operate for 20 years or more. This is the opening sentence of a new encyclopedia of the cosmos. If such a profound discovery can be made in a seemingly ordinary stellar nursery, what will we find when we point Webb at the most exotic and mysterious objects we know of? What will we see when we look at the atmospheres of nearby exoplanets, at the center of our own galaxy, or at the most distant ancient quasars? This image is both a destination and a signpost. It is a stunning revelation in its own right, and it points the way toward an era of discovery that will likely reshape our understanding of the universe in ways we cannot yet even begin to imagine. The silence is just the beginning. This discovery also subtly alters our relationship with time. We often perceive the deep past as something static and gone forever. But this image reminds us that the past is an active, ongoing phenomenon. Because of the finite speed of light, the history of the universe is not just a story in a book. It is a visible, observable landscape. We can literally see the past unfolding before our eyes. The ancient light from this protostellar nursery is arriving at Earth right now. The telescope allows us to be present at an event that took place across the galaxy thousands of years ago. It collapses the immense distance of time and space, making us direct witnesses to cosmic creation. We are not just looking at a picture of the past. We are receiving the past, a continuous stream of history flowing over us at the speed of light. This rapid planet formation model, gravitational instability, also has intriguing implications for the kinds of planets that are formed. Unlike the slow core accretion method, which favors the formation of rocky cores first, direct collapse can form massive gas giants that may not have a solid core at all. They would be vast turbulent spheres of hydrogen and helium, more like failed stars than the planets in our own solar system. This opens up the possibility of entirely new classes of worlds. Furthermore, the chaotic dynamics of this rapid formation could eject planets from their parent system entirely, sending them wandering through the interstellar darkness as rogue planets. Our galaxy could be filled with these dark, orphaned worlds, each one a product of a violent and rapid birth. The Webb image is not just a picture of a solar system. It is a glimpse into a process that may populate the galaxy with unseen billions of solitary wanderers. Let us also consider the chemical resilience implied by the discovery of complex molecules in such a harsh environment. A protostar is a source of intense ultraviolet and X-ray radiation, which should, in theory, be very effective at breaking down the delicate chemical bonds of organic compounds. The fact that these molecules are not only surviving but are abundant suggests they may be protected. Perhaps they are shielded within the interiors of icy dust grains, like seeds in a protective shell. Or perhaps there is an unknown chemical pathway that is actively regenerating these molecules as fast as they are destroyed. Either possibility is profound. It suggests that the chemistry of life is not a fragile, delicate thing, but a robust, persistent, and self-sustaining process that can withstand the most violent phases of stellar creation. Life's precursors are not hothouse flowers. They are hardy weeds, capable of thriving in cosmic fire. The discovery pushes back the timeline for when life could have started in the universe. But it also deepens the mystery of the Great Silence. If the conditions for life are so common and arise so quickly, then the universe has had over 13 billion years to produce intelligent, technological civilizations. The very first Earth-like planets seeded with organics could have formed when the universe was only a fraction of its current age. A civilization that arose on such a planet would have a head start of billions of years on us. The sheer scale of that time gap is incomprehensible. What does a civilization become with a billion years of continuous development? It is possible they have transitioned to forms of existence we cannot recognize or communicate in ways we cannot detect. The Webb image makes the universe seem more full of potential, but it makes the silence of our neighbors more deafening and more profound. The image is, in essence, a weather report from a distant time and place. The weather it reports is the swirling winds of gas and dust. The temperature is the infrared glow of creation, and the atmospheric composition is the spectrographic analysis of its organic chemicals. But it is a weather report with a forecast of monumental significance. The forecast is for planet formation, for the delivery of life's building blocks, and for the creation of new worlds. It tells us that the cosmic weather in these stellar nurseries is consistently favorable for the conditions that we know led to our own existence. It suggests that the forecast is the same across vast regions of the galaxy. We are seeing a local report that hints at a universal climate, a climate of creation, a climate of potential, a climate of life. In the end, the speechless awe induced by this image is a reflection of a fundamental human need, the need for meaning and connection in a vast cosmos. The image provides a powerful dose of both. It connects us to our own origins, showing us the kind of environment where our sun was born. And it gives us a sense of meaning by suggesting that the emergence of complexity, planets, and the chemistry of life is not a random accident, but a coherent and recurring process of the universe itself. We are not a fluke. Our existence is a reflection of a deep underlying cosmic tendency. The image quiets us because it speaks to a place deeper than language, a place where science and philosophy merge, a place where we can feel, for a moment, an undeniable sense of belonging to the grand, unfolding story of the stars. Let us further contemplate the schism between the two models of planetary creation, the slow, patient accretion versus the swift, dramatic instability. The core accretion model is a narrative of gradualism, akin to a coral reef growing over millennia, particle by particle. It is a story of patience and persistence. Gravitational instability, in contrast, is a story of revolution. It is a cosmic thunderstorm where vast regions of the protoplanetary disk, under the right conditions of mass and temperature, collapse under their own weight in a sudden, breathtaking frenzy. This process doesn't build planets, it births them, whole and massive, in a geological eye blink. The Webb image, with its impossibly mature structure, serves as the strongest evidence yet that the universe may favor these revolutionary bursts over slow, evolutionary change. It suggests that the formation of a solar system might be less like the gentle growth of a tree and more like a cosmic forest fire, clearing the way for new worlds to emerge from the chaos with astonishing speed. The aesthetic difference between these two models is profound. Core accretion paints a picture of a relatively placid, orderly disk where gravity slowly and gently coaxes matter together. Gravitational instability, however, paints a far more violent and beautiful picture. It envisions a disk that writhes and fragments, forming magnificent spiral arms of gas and dust, not unlike a miniature galaxy. These arms, dense with matter, become the birthing canals for new planets, which light up as they collapse and heat up. The image from Webb, showing those clean rings, is a snapshot taken after the storm has passed. It is the serene aftermath of a violent creation event. We are looking at the beautifully ordered consequence of a magnificent, chaotic cause. The universe, it seems, employs moments of profound violence to forge its most stable and elegant structures, creating a lasting peace through a brief and spectacular war of gravity. The existence of the gravitational instability model also changes our understanding of the average solar system. If the slower core accretion model were the only method, we would expect most solar systems to look somewhat like our own, with smaller rocky planets in the inner regions and large gas giants far out. But a rapid, chaotic formation process allows for a much wider range of outcomes. It can create multiple gas giants in eccentric, crossing orbits. It can form planets in wide orbits that would be impossible to form via slow accretion. It can scatter smaller bodies throughout the system in unpredictable ways. This helps to explain the bewildering variety of exoplanetary systems we have already discovered. The Webb image provides a key insight. The diversity of solar systems in the galaxy is not an anomaly to be explained away, but is the direct, expected consequence of a formation process that is fundamentally more chaotic, rapid, and creatively versatile than our own placid origins might suggest. Now let us return our focus to the light and the chemical story it tells. The detection of polycyclic aromatic hydrocarbons is more than just finding soot in space. It is about finding a key piece of molecular scaffolding. These PAH molecules, with their stable ring structures, are incredibly versatile. They can act as platforms upon which other, simpler molecules can attach and react, facilitating the creation of even more complex organic compounds. They are, in essence, microscopic chemical laboratories floating in the void. Furthermore, when struck by ultraviolet radiation from the young star, they can become ionized and play a crucial role in the heating and cooling of the gas in the disk, influencing the very dynamics of planet formation. So these molecules are not passive ingredients, they are active agents. They are both the bricks for building life and the chemical engineers that help to shape the construction site itself. The spectral signature of these molecules, the unique barcode of dark lines in the starlight, is a message of astonishing fidelity. Consider that this light has traveled for thousands of years through the interstellar medium. It has been stretched by the expansion of space. It is unimaginably faint. Yet, when it arrives at Webb's mirrors, it still carries the precise, unaltered fingerprint of the molecules it passed through in that distant infant solar system. The universe preserves information with incredible care. The darkness between the colors of a spectrum is as meaningful as the light itself. Each dark line is a testament to a specific molecular interaction, a story of a photon being absorbed to excite an atom in a specific way. To read a spectrum is to read a history book written in a language of missing light, and Webb is the most fluent reader humanity has ever built. The story of these organic molecules is a story of cosmic inheritance. The carbon, oxygen, and other heavy elements that constitute them were not created in the Big Bang. They were forged in the hearts of a previous generation of massive stars. When those stars reached the end of their lives, they exploded as supernovae, casting these newly created elements out into the galaxy. For millions of years, this enriched material mixed with interstellar gas and dust, forming a vast, fertile cloud. It is from this second-hand recycled material that the young star in the Webb image and its surrounding disk were born. The complex molecules are therefore a direct link between a star that is dying and a solar system that is just being born. It is the universe's grand cycle of death and rebirth, written in the language of chemistry. We are not just stardust, we are the children of recycled stars. This cycle of cosmic recycling has profound implications for the distribution of life's potential. It means that the longer a galaxy exists, the more enriched it becomes with the heavy elements and complex molecules necessary for life. Older galaxies should, in theory, be more fertile than younger ones. Our own Milky Way is a mature galaxy, having undergone this enrichment process for over 12 billion years. The gas cloud that formed our solar system was already rich with the ashes of countless prior stellar generations. The Webb image shows this process happening elsewhere, confirming that our own origins were not unique. It demonstrates that the galaxy is a self-enriching ecosystem, constantly upgrading its own potential for life with every star that dies. The universe learns from its own history, folding the lessons of the past into the raw material of the future. The abundance of these prebiotic molecules also challenges a long-held assumption about Earth's history known as the late heavy bombardment. This theory posits that a significant portion of Earth's water and organic compounds were delivered by a massive spike in comet and asteroid impacts hundreds of millions of years after the planet formed. While this likely did happen, the Webb image suggests it may not have been the only or even primary source of our organic inventory. If Earth formed from a disk that was already saturated with these compounds, then our planet was born with its organic ingredients already mixed in. The late heavy bombardment might have been a top-up, rather than the main delivery. This makes the emergence of life feel less like a lucky accident dependent on a later celestial delivery service, and more like an innate potential, a chemical destiny waiting to be unlocked within the very rocks and waters of the primordial Earth. Let us also consider the water. The spectrographic analysis performed by Webb is not limited to organic molecules. It is also exquisitely sensitive to the signature of water vapor. And in this young disk, Webb has detected vast quantities of it. This is not liquid water, but gaseous water molecules, mixed in with the hydrogen and dust. Crucially, this water is present in the same inner regions of the disk, where the organic molecules are found and where rocky planets are expected to form. This means that from the very beginning, the three essential ingredients for life as we know it, a source of energy from the star, complex organic molecules, and water, are all present and co-located in the planetary construction zone. The universe is not just providing the ingredients separately, it is mixing them together in the right place, at the right time. It is a recipe for life, written into the very fabric of a nascent solar system. This co-location of water and organics solves a major chemical problem. While dust grains can be excellent surfaces for building complex molecules, ice is even better. The surfaces of frozen water crystals provide a unique template for organic chemistry, helping to align simple molecules so they can react to form more complex chains. The fact that the disk is rich in both means that countless icy dust grains are acting as microscopic factories, efficiently assembling the precursors to life. The image from Webb is therefore not just a picture of dust and gas. It's a picture of a trillion-mile-wide chemical reactor, powered by the light of a newborn star that is actively and efficiently generating the very compounds that may have led to our own consciousness. We are witnessing the large-scale industrial chemistry of biogenesis. Revisiting the Fermi paradox, where is everybody? With this new information adds a layer of chilling grandeur to the question. The evidence from Webb suggests that the universe is a garden, and the seeds of life are being sown everywhere, constantly. It dramatically increases the probability of life emerging elsewhere. So why the silence? Perhaps the bottleneck is not the emergence of life, but the emergence of intelligence. Life could be incredibly common, with countless worlds existing as microbial mats or simple aquatic ecosystems for billions of years. But the evolutionary leap to complex, tool-using, radio-building intelligence might be the astronomically rare event. The universe could be teeming with life, but it might be a silent, simple life. We might be living in a cosmic jungle, full of unseen creatures, but we are the only ones, so far, who have tried to shout. Another possibility to consider, a more humbling one, is that technological civilizations are common, but short-lived. The very intelligence that allows a species to develop technology and reach for the stars may also give it the capacity for self-destruction through warfare, environmental collapse, or misuse of powerful technologies. This is the Great Filter Theory. If the average lifespan of a technological civilization is only a few thousand, or even a few 100,000 years, then the chances of two such civilizations existing at the same time and close enough to communicate are vanishingly small. The cosmic silence in this view is the sound of a graveyard of bygone empires. The Webb image shows us how easy it is to begin the story of life, but history and logic warn us how difficult it may be to write a long and happy ending. There is a more optimistic and perhaps more profound solution to the silence. Perhaps the most advanced civilizations are not silent, but are simply operating on a level we cannot perceive. Our search for extraterrestrial intelligence is based on the technologies we understand: radio waves, lasers. This is like searching the ocean for whales by listening only for the sound of drums. An older, more advanced civilization may have unlocked the physics of space-time, or communicate through quantum entanglement, or have transitioned their consciousness into a non-physical substrate. Their communication might be all around us, embedded in the structure of space-time, or in the fluctuations of the quantum vacuum. The silence we perceive might not be an absence of signal, but a failure of our receivers. We may be like ants crawling on a supercomputer, utterly unaware of the vast intelligence operating on a dimension we cannot even comprehend. This new, earlier timeline for planetary formation also forces us to consider the evolution of stars themselves. The very first stars in the universe, known as population 3 stars, were thought to be incredibly massive. Hundreds of times the mass of our Sun, they would have lived very short, very violent lives, burning through their fuel in only a few million years before exploding. It was long thought that these first stars were unsuitable for life-bearing planets. But the Webb image, with its story of hyperfast planet formation, opens a strange new possibility. Could planets have formed around these primordial, short-lived giants in the cosmic dawn? Such worlds would have been fleeting, bathed in intense radiation, and likely destroyed when their parent star exploded. But for a brief moment, they would have existed, the very first planets in the entire universe. A brief, failed first draft of creation. Let us reflect on the instrument itself, the James Webb Space Telescope, as a philosophical object. It exists in a unique state of equilibrium at the second Lagrange point, a place where the gravitational pull of the Sun and the Earth combine to create a stable pocket in space. It is balanced perpetually between these two massive celestial bodies. To do its job, it must remain incredibly cold, less than 50 degrees above absolute zero. To achieve this, it must constantly face away from the Sun, Earth, and Moon, hiding behind its 5-layered sun shield. It is a machine that must turn its back on its own home, on the warmth of its own star, in order to see the more ancient, fainter light of distant creation. There is a deep poetry here. To gain a greater perspective, to see the bigger picture, we must achieve a state of separation and profound coldness, isolating ourselves from the familiar in order to perceive the truly new. The sunshield of the Webb telescope is a marvel of material science and engineering. Each of its 5 layers is thinner than a human hair, made of a material called capton and coated with aluminum and doped silicon. As heat radiates from the Sun, it is reflected by the first layer. The heat that gets through is then reflected by the second, and so on. This passive cooling system creates a temperature difference of nearly 600 degrees Fahrenheit from the hot, sun-facing side to the cold, space-facing side, where the mirrors reside. It is, in essence, a high-tech parasol, creating a pocket of permanent, deep space shadow for the telescope to live in. The ability to see the faint heat of the Big Bang is entirely dependent on the ability to create this artificial eclipse, to manufacture a small piece of perfect, cold night in the middle of the solar system. The mirrors of the telescope represent another pinnacle of human achievement. They are made of beryllium, a metal that is both incredibly strong and lightweight, and which holds its shape at cryogenic temperatures. But beryllium is not very reflective in the infrared. So each of the 18 hexagonal segments was coated in a microscopically thin layer of pure gold, applied through a process of vapor deposition. Gold is one of the most effective materials for reflecting infrared light. The total amount of gold used was only about 48 grams, enough to make a single golf ball. This tiny amount, spread in a layer only 100 nanometers thick, is responsible for gathering the ancient light that is rewriting our understanding of the cosmos. Humanity sent a golden eye into the void, and in return, the universe has shown us a golden age of creation. The Webb telescope can be seen as a new sensory organ for the human species. Our eyes evolved to see a narrow band of the electromagnetic spectrum, the one most useful for survival on the surface of this particular planet. For millennia, that was our only window on the universe. Then we built telescopes that could see in other wavelengths: radio, X-ray, gamma ray, each one opening a new, unseen cosmos. The Webb telescope is our first true, high-fidelity eye for the infrared universe. It allows us, as a collective, to perceive a fundamental aspect of reality that was previously invisible. It is an extension of our consciousness, a prosthetic for our curiosity. The speechless awe of the astronomers is the feeling of a new sense being used for the first time, of a veil being lifted, and a whole new layer of existence being revealed in breathtaking detail. This synthesis of rapid planet formation and abundant organic material creates a powerful synergistic effect. It is not just that two interesting things are happening, it is that they are happening together in a way that amplifies their significance. The fast track to building planets means that the organic molecules, which are also present from the start, have a stable home to go to much more quickly. They spend less time being exposed to the harsh radiation of interstellar space. The rapid formation of gas giants, a key feature of the instability model, provides the gravitational slingshot mechanism to deliver organic-rich material from the outer disk to the inner terrestrial planets. The two discoveries are not independent. They are two parts of a single, highly efficient system for creating potentially habitable worlds. It is a cosmic machine with two interlocking gears, both turning faster than we thought, driving the universe toward complexity. The image from Webb does not solve the mystery of our existence, but it deepens it in a beautiful way. It replaces a story of cosmic loneliness and improbable luck with a story of cosmic fecundity and inherent potential. It suggests that the universe is not a barren wasteland with one lucky spark of life, but a fertile field where the seeds are sown broadcast, in every direction, at all times. It shifts our self-perception from being a cosmic accident to being a cosmic inevitability. We are no longer the one winning lottery ticket among trillions of losers. Instead, we may be just one of countless winners in a game that is designed to produce them. This is a more humbling but also a more comforting and magnificent vision of our place in the cosmos. The silence it induces is not one of fear, but of profound, peaceful, and awe-filled belonging. Let us contemplate the texture of that protoplanetary disk. The rings are not perfectly smooth. The images show clumps and asymmetries, regions where matter is denser and gravity is beginning to win. These are the epicenters of creation, the specific locations where new worlds are struggling to be born. To look at this image is to witness the weather of cosmogenesis. We see high-pressure systems of gas and dust, gravitational fronts moving through the disk, and the turbulence kicked up by the unseen, newly formed planets. It is a dynamic, living system. For a long time, we have modeled these disks as smooth, idealized mathematical objects. Webb is showing us the messy, complex, and far more interesting reality. We are moving from the clean blueprint to the chaotic, muddy, and glorious construction site, and it is in that messiness that the true secrets of creation are found. The spectral analysis that revealed the organic molecules also revealed the presence of silicates, the primary component of rock. This is not surprising, but the form of these silicates is. Webb can distinguish between amorphous silicates, which have a disordered glassy structure, and crystalline silicates, which have a neat, ordered lattice structure like quartz. Crystalline silicates can only be formed in high-temperature environments, close to the star, yet Webb is finding them in the cold, outer regions of the disk. This implies that there is a large-scale circulation system within the disk, like a great conveyor belt, that dredges up material from the hot inner regions and transports it to the cold outer regions, and vice versa. This constant mixing ensures that the entire disk, from its fiery heart to its icy rim, is chemically and physically connected, a single, unified system for building a diverse family of worlds. This idea of a grand, disk-wide circulation system reinforces the theme of unity and interconnectedness. No part of the nascent solar system is an island. The material that will form the outer gas giants is mixed with the material that will form the inner rocky worlds. The water from the icy outer regions is delivered to the dry inner regions. The organic molecules, forged in the furnaces of long-dead stars, are distributed evenly throughout the construction site. It is a profoundly holistic process. A planet is not just a product of its local environment. It is a product of the entire disk's history and dynamics. This means that to understand our own Earth, we must understand the history of Jupiter, the composition of the asteroid belt, and the journey of comets from the Oort cloud. The Webb image is a family photo, and it reminds us that all the members of a solar system are related by their shared origin in a single, turbulent, and unified cloud of stardust. The speed of planet formation has significant implications for the development of life. A planet that forms quickly also cools down quickly. On early Earth, this rapid cooling would have allowed a solid crust to form and liquid water to pool much sooner than previously thought. This extends the amount of time available for prebiotic chemistry to work its magic and for life to emerge. The old models suggested a long, fiery Hadean eon, where Earth was a molten hellscape for hundreds of millions of years. The new model, prompted by Webb's data, suggests that the habitable phase of a planet's life might begin almost immediately after its formation. The window of opportunity for life is thrown open much wider, not just across the cosmos, but on each individual world. The curtain rises on the theater of life much earlier than we ever dared to imagine. Let us consider the unseen planets themselves, the ghostly architects carving the gaps in the disk. While Webb cannot see them directly yet, it can infer their presence and even estimate their mass by the size and shape of the gaps they create. These are infant worlds, still glowing with the heat of their own formation. They are not the cold, placid planets we know today, but turbulent spheres of gas and molten rock. They are in the most dynamic and chaotic phase of their existence, battling for gravitational dominance and shaping the destiny of their entire solar system. The clean gaps are a sign that these young titans have already won their local battles, establishing a new kind of order. The image is a monument to their invisible power, a testament to the unseen forces that impose structure and pattern upon the cosmos. The discovery of complex organics in such a primordial state gives credence to a fascinating theory known as molecular evolution. This idea posits that the principles of Darwinian evolution, reproduction, variation, and selection may apply not just to biological organisms, but to molecules themselves. In the chemical soup of a protoplanetary disk, some molecules, due to their inherent stability or ability to catalyze their own formation, would be more successful than others. They would replicate more effectively, becoming more abundant over time. This process could, over millions of years, lead to a gradual increase in chemical complexity, a kind of survival of the fittest for molecules that inexorably pushes a chemical system towards the threshold of life. The Webb image, showing a rich and complex molecular environment, could be a snapshot of this prebiotic evolution in action. This image is also a profound lesson in humility. For centuries, our cosmological models have been, by necessity, based on the one data point we had, our own solar system. We assumed its structure and history were typical. This led to a kind of scientific geocentrism, where we placed our own home at the center of the theoretical universe. The thousands of exoplanets discovered in recent decades began to challenge this, but the Webb image delivers a powerful blow. It shows us a system being born in a way that is dramatically different and faster than our own. It forces us to decenter our own experience and to accept that our solar system may be just one of many possible outcomes, and perhaps even an outlier. The universe is more creative and varied than our one example led us to believe. The silence of the astronomers was the sound of a geocentric assumption quietly dissolving. Let us think about the name of the telescope's location, Lagrange Point 2. It is named after Joseph Louis Lagrange, an 18th century mathematician who studied the three-body problem. He discovered that in any system with two large orbiting bodies, like the Sun and Earth, there are 5 special points where a third, smaller body can maintain a stable position. These points are pure mathematical abstractions, places where gravitational forces cancel out in a perfect, elegant balance. The fact that we can calculate the existence of such a point and then place our most advanced scientific instrument there is a triumph of the human intellect. It is a moment where the abstract, beautiful world of mathematics and the physical, engineered world of a real spacecraft become one. The telescope's very location is a testament to the power of pure thought to map and navigate the invisible forces of the cosmos. The discovery of rapid planet formation might also influence the search for biosignatures in the atmospheres of exoplanets. A biosignature is a gas, like oxygen or methane, that could indicate the presence of life. If planets become habitable much earlier in their lives, then we should perhaps not neglect very young star systems in our search. It is conceivable that primitive, microbial life could arise and begin to alter a planet's atmosphere within a few 100 million years of its formation. This means that a planet that is only 500 million years old might already be exhibiting telltale signs of biology. Webb's primary mission includes studying exoplanet atmospheres, and this new understanding of timelines will help to prioritize targets, potentially pointing us towards younger, more dynamic systems where the story of life may be just beginning to be written in the chemistry of the air. The awe inspired by the Webb image is ultimately an experience of connection to something larger than ourselves. It breaks down the perceived barrier between our small, personal worlds and the vast, impersonal cosmos. By revealing the shared chemistry, the shared processes, and the shared stardust, it makes the universe feel less alien. It fosters a sense of kinship with the distant nebula and the forming worlds. It is a reminder that the laws of physics and chemistry that govern our own bodies are the same laws that govern the birth of galaxies. We are not just observers of the universe, we are an expression of it. The speechless moment is a moment of profound recognition, a fleeting but powerful realization that the observing consciousness and the observed cosmos are not two separate things, but are two aspects of a single, magnificent, unfolding reality. Consider the sheer coldness required for this observation. The instruments on Webb must be colder than any natural place in our solar system to reduce their own thermal noise. If the telescope were even slightly warmer, its own heat would blind it, like trying to take a photo of a distant candle while standing inside a bonfire. To achieve this, beyond the passive cooling of the sunshield, Webb uses an advanced cryocooler. This device is a masterpiece of mechanical engineering, a refrigerator that uses helium gas to chill the mid-infrared instrument down to a staggering 7 Kelvin, just a few degrees above absolute zero, the theoretical point where all atomic motion ceases. This extreme cold is the secret to Webb's penetrating vision. It is only by achieving a state of near-perfect stillness and cold that we can perceive the faint, ancient heat of the universe's most dynamic and fiery creative moments. The data from the telescope is transmitted back to Earth as a stream of radio waves, a silent river of ones and zeros. It takes this signal, traveling at the speed of light, about 5 seconds to cross the million-mile gap from the telescope to the Deep Space Network antennas on Earth. This data is then processed through complex algorithms, corrected for cosmic ray hits, and calibrated by teams of scientists before it can be assembled into a visual image. What we see as a single beautiful photograph is actually a carefully constructed mosaic of information, a translation of pure data into a form our eyes can appreciate. The final image is as much a work of art and computer science as it is a work of physics. It is a collaboration between the universe, the telescope, and the human mind, each playing an essential role in bringing the vision to light. This image is a powerful antidote to the phenomenon of cosmic vertigo, the feeling of insignificance and fear that can arise when contemplating the vastness of space. Instead of making us feel small and meaningless, it does the opposite. It shows that the most complex and meaningful things we know of, the building blocks of life, are not confined to our small world but are a universal heritage. It suggests that the cosmos is not empty, but is filled with the potential for meaning. It replaces the vertigo of emptiness with the awe of interconnectedness. We are not lost in the void. We are floating in a cosmic ocean that is rich with the very same elements and possibilities that gave rise to us. We are, in the most literal sense, at home in the universe. The discovery of such rapid ordering in a protoplanetary disk resonates with modern complexity theory. This field of science studies how complex, ordered patterns can spontaneously emerge from the simple interactions of many individual components, a phenomenon known as self-organization. We see it in the flocking of birds, the formation of snowflakes, and the crystallization of minerals. The Webb image suggests that solar systems are another profound example of this principle. The elegant rings and gaps are not the result of a grand design, but the emergent consequence of countless simple gravitational and physical interactions between particles of dust and gas. The universe, it seems, has a built-in tendency to create order from chaos, to spontaneously generate pattern and structure without a guiding hand. It is a testament to the creative power embedded in the fundamental laws of physics. The implications of this discovery will ripple through science for decades. Textbooks will be rewritten. Planet formation simulations will need to be reprogrammed with new initial conditions. The search for life will be reoriented, but perhaps its most significant impact will be on the next generation of scientists, the children and students who see this image today. For them, a universe of rapid, life-rich creation will not be a shocking new discovery, but the baseline assumption from which they begin their own explorations. This image will seed their imaginations, inspire their career choices, and shape the questions they will ask. The speechless awe of today's astronomers is the seed of the articulate, revolutionary science of tomorrow. We are witnessing a moment that will define the intellectual landscape for a generation to come. Let's consider the nature of speechlessness itself. It is a state where intuitive, emotional understanding outpaces our linguistic, analytical ability to describe it. The astronomers who first saw the image did not know less. In a way, they knew more, but on a level that transcended their vocabulary. They apprehended the gestalt, the whole picture, at once. The impossible speed, the unlikely chemistry, the profound implications, and the sheer weight of this holistic understanding overloaded the circuits of language. This is often the nature of true revelation. It does not come as a neat, well-formed sentence, but as a sudden, overwhelming, and deeply felt insight. The words come later, as we struggle to translate that ineffable moment of knowing into a shareable, comprehensible form. The presence of polycyclic aromatic hydrocarbons may also have played a role in the formation of our own planet's most vital resource, carbon. While most of Earth's carbon is locked away in the core and mantle, the carbon available for life on the surface is a precious commodity. These PAH molecules, being carbon-rich, could be a highly efficient mechanism for seeding the surface layers of a forming planet with this essential element. Instead of relying on the slow outgassing from volcanoes, a planet born in a PAH-rich environment would have a head start, its crust and early atmosphere already endowed with the carbon needed to build the organic chemistry of life. The Webb image thus provides a plausible explanation for why a planet like Earth would be so well equipped for biology from its earliest moments. The stability of the rings in the image is also a puzzle. Over time, the gravitational jostling between planets and the drag from the remaining gas should cause these sharp structures to blur and dissipate. The fact that they are so well defined suggests we are looking at them at a very specific, privileged moment in time, shortly after their creation. Or it could imply that there is an active process that maintains this order, perhaps related to the resonant orbits of the planets involved. This would mean the system has already settled into a deep, long-term stability that belies its young age. It is like meeting a newborn infant who already has the wisdom and composure of an old master. The system's physical maturity is as baffling and profound as its chemical maturity. This image is a powerful tool for perspective. When we are caught up in our daily struggles and conflicts, the universe can seem to shrink to the size of our immediate problems. An image like this shatters that illusion. It lifts our gaze and forces us to confront a scale of time and space where our own concerns become vanishingly small. Yet, it does so without devaluing us. Instead, it recontextualizes us. It shows us that we are part of a story so grand, so ancient, and so magnificent that it can inspire nothing but awe. It is a form of therapy, a cosmic recalibration of the soul that reminds us of the incredible, beautiful, and vast reality of which we are a small but meaningful part. It offers the profound peace that comes from seeing the bigger picture. The search for life has often been framed as a search for another Earth. This image subtly suggests we should reframe that goal. We should perhaps be searching for the process of life's emergence, not just the final outcome. By studying systems like this one, we are not just looking for planets, we are looking for the conditions of creation. We are trying to understand the universal recipe. This is a more fundamental and perhaps more achievable goal. If we can understand the sequence of events, the formation of the disk, the carving of the gaps, the enrichment with organics, the delivery of water, we can then predict where we are most likely to find the finished product. The Webb image is our first clear look at the factory floor, and it is teaching us more about the product than 1,000 distant glimpses of the showroom ever could. Let us reflect on the darkness in the image. The blackness between the glowing rings and distant stars is not empty. It is the interstellar medium, a thin soup of gas and dust. But more profoundly, it is the backdrop of space-time itself, the stage upon which all of this unfolds. The image's power comes from the contrast between the brilliant light of creation and the profound, silent dark. The darkness gives the light its meaning. It is the canvas of possibility, the state of non-existence from which new worlds are summoned by the laws of physics. In our own lives, we often fear the dark, the unknown. But this image teaches us that the darkness is where all potential resides. It is the quiet, patient womb of the cosmos, from which all light and life are eventually born. The scientific teams that analyze this data are global collaborations involving researchers from dozens of countries. In a world often marked by division and conflict, the James Webb Space Telescope is a shining example of what humanity can achieve when it works together towards a common, noble goal. The light it gathers does not belong to one nation. It is a gift to all of humankind. The speechless moment was shared across borders, languages, and cultures. It is a reminder that our curiosity, our desire to understand our place in the universe, is a universal human trait that can transcend our differences. The telescope is not just an instrument of science, it is an instrument of peace, a project that unites us in a shared sense of wonder. The implications for our own future are also worth contemplating. If the universe is so adept at creating the conditions for life, it suggests that life is a robust and resilient phenomenon. This is an optimistic message for our own species on our own planet. While we face immense challenges, the cosmic perspective reminds us that the fundamental tendency of the universe is towards creation and complexity, not destruction and simplicity. It suggests that life, once it takes hold, is not easily extinguished. This does not absolve us of our responsibility to be good stewards of our world, but it provides a hopeful backdrop, a sense of a universal wind at our backs. The cosmos, it seems, is on the side of life. This image is a form of time travel. The light from this system may have taken thousands of years to reach us. When we look at it, we are seeing the system as it was when civilizations on Earth were just beginning to develop agriculture. We are opening a window into the deep past, but in a sense, it is also a window into the future. By seeing how solar systems are born, we gain a deeper understanding of the long-term evolutionary processes that will shape our own solar system for billions of years to come. The image connects our past and our future, showing us both our origins and the universal laws that will govern our ultimate destiny. It is a bridge across eons, a single frame that captures the eternal, cyclical nature of cosmic time. Let us again focus on the feeling of awe. Psychologists define awe as the emotion we feel in the presence of something vast that transcends our current frame of reference. It has two components, a sense of vastness and a need for accommodation, the struggle to update our mental models to make sense of the new information. Awe has been shown to have profound psychological benefits. It can decrease stress, increase feelings of connection to others, and inspire creativity. The Webb image is a powerful and efficient awe delivery mechanism. It is a tool for mental and spiritual expansion, offered freely to anyone who is willing to look. The speechless moment is not a bug. It is the primary feature, the intended psychological effect of a direct encounter with the sublime. What happens after the speechlessness fades? It is replaced by a renewed sense of purpose. The astronomers who were momentarily stunned are now energized, filled with new questions and new avenues for research. The image is not an endpoint. It is a starting pistol for a new race of discovery. They will now push for more observation time, design new research programs, and develop new theories to explain these baffling and beautiful results. The awe does not lead to passivity, but to action. It is the fuel that powers the engine of science. The silence was the deep breath taken before the plunge into a whole new ocean of inquiry. An ocean that is deeper, richer, and more full of wonders than they had ever realized. The rings and gaps of the disk can be thought of as a form of cosmic writing. It is a message, written in the language of gravity and dust, that tells a story of creation. We are just now learning to read this language. The letters are the dust grains, the words are the rings, and the syntax is the law of physics. It is a story with no author, but with profound meaning. It tells of the universe's inherent capacity to generate order, complexity, and the potential for life. Like ancient hieroglyphs, we are deciphering them slowly, piecing together the grand narrative of our cosmic origins. The speechless moment was the moment we recognized it as a language, before we could even begin to translate the first word. This discovery ultimately empowers us. By understanding the processes that created our world, we gain a deeper understanding of ourselves. Knowledge of our cosmic context is not a trivial pursuit. It is fundamental to answering the question, what are we? The Webb image provides a crucial part of the answer. We are the product of a universe that is biased towards creation. We are the result of a rapid, efficient process that seeds new worlds with the building blocks of life. We are made of stardust that has been recycled through generations of stars. This knowledge is empowering because it gives us a firm, scientific grounding for our own existence. We are not a cosmic mistake, but a cosmic masterpiece in the making. Consider the possibility that life on Earth is not the first, or even the most advanced, to arise from this process. If solar systems have been forming this rapidly and this richly for over 13 billion years, it is statistically very likely that we are not the first. We may be one of the younger children in a very large, very old cosmic family. This thought can be humbling, but also comforting. It means we are not alone in our journey of evolution and consciousness. Others may have walked this path before. Their stories, their successes, and their failures may be written in the light of distant stars, waiting for us to become wise enough to read them. The silence, then, is the respectful quiet of a student entering a library that is billions of years old and contains more books than we can ever imagine. And so, we return to the quiet, profound stillness of that image. It is a portrait of a process that is both timeless and immediate. It happened to this system thousands of years ago, it happened to our system billions of years ago, and it is happening in countless other nebulae right now. The image is a single frame from an eternal movie of cosmic creation. It is a reminder that the universe is not a static, finished object, but a dynamic, ongoing verb. It is constantly becoming, constantly creating, constantly turning dust into dreams. To look upon this image is to witness the sacred act of creation itself, and the only proper response is a deep, meditative, and grateful silence. A silence filled, not with emptiness, but with the quiet, overwhelming hum of a universe that is profoundly, relentlessly, and beautifully alive. Let us consider the role of carbon in this grand cosmic narrative. Carbon is unique among the elements. With its 4 valence electrons, it can form 4 strong, stable bonds with a wide variety of other elements, including itself. This allows it to create long chains, complex rings, and intricate branching structures, forming the molecular backbone of all known life. It is the ultimate atomic Lego brick. The discovery that the universe is not only capable of creating carbon in the hearts of stars, but is also adept at pre-assembling it into complex organic structures like PAHs in the earliest stages of solar system formation is deeply significant. It implies that the universe is not just producing the raw materials for life, it is taking the first crucial steps of construction. It is delivering not just a pile of bricks, but prefabricated walls and trusses, making the final assembly of a living organism a far less improbable task. The cosmos, it seems, is an expert organic chemist, working on a galactic scale. The implications of this for the Drake equation are profound. The Drake equation is a probabilistic argument used to estimate the number of active, communicative, extraterrestrial civilizations in the Milky Way. One of its key variables is, FL, the fraction of planets that could support life on which life actually appears. For decades, this has been one of the most uncertain terms, with estimates ranging from near certainty to vanishingly small. The Webb image provides the first hard, observational evidence to suggest that this fraction might be very high. If the raw materials for life are not just present, but are abundant, pre-organized, and delivered efficiently to newly formed worlds, then the chemical hurdles to abiogenesis are significantly lowered. The transition from non-life to life may be less of a miraculous leap and more of a predictable, almost inevitable outcome of planetary chemistry. The universe may not just permit life, it may encourage it, fostering it into existence whenever the conditions are even remotely suitable. This image forces us to confront the philosophical difference between purpose and inevitability. Does the universe have a purpose to create life? This is likely the wrong question, as it implies a form of intention or consciousness. A more scientific, and perhaps more beautiful way to frame it, is that the laws of physics and chemistry themselves, as they exist in our universe, have an inherent bias towards complexity. The properties of gravity, the bonding rules of carbon, the behavior of matter in an accretion disk, these fundamental, unintelligent laws, when allowed to play out over vast scales of time and space, inevitably lead to the emergence of ordered structures, planets, complex molecules, and potentially life and consciousness. Life is not the purpose of the laws, it is a consequence of them. We are not a preordained goal, but the beautiful and complex result of a physical logic that pervades the entire cosmos. Let us also consider the role of chaos in this process. While the final image of the rings is one of profound order, the process that created it, gravitational instability, is fundamentally chaotic and violent. It is a storm of colliding gas clouds and gravitational collapse. This is a recurring theme in the cosmos. Order emerges from chaos. A star is born from the chaotic collapse of a nebula. A stable planetary orbit is the long-term result of a chaotic dance of countless planetesimals. Life itself on Earth is shaped by chaotic events, like asteroid impacts and volcanic eruptions. The Webb image is a portrait of this fundamental dialectic. It teaches us that the universe does not create in a clean, linear fashion. It uses the turbulent, unpredictable engine of chaos to forge the enduring, elegant structures of order. The beauty we see is not the absence of chaos, but the result of chaos being tamed and channeled by the fundamental laws of nature. The very existence of the James Webb Space Telescope is a statement about the nature of consciousness. A universe of unconscious matter, of mindless gas and dust, simply is. It has no awareness of its own grandeur. It is only through the evolution of a conscious mind, on at least one planet, that the universe becomes aware of itself. The telescope is the universe's way of looking back at its own history. The carbon atoms in the Astronomers, forged in ancient stars, are observing their chemical cousins in a distant, nascent solar system. It is a profound act of cosmic self-reflection. The speechless awe is the sound of the universe, recognizing its own beauty and complexity through a sensory organ that it took 13.8 billion years to build. We are not just in the universe, we are the universe experiencing itself. We must also acknowledge the role of information in this cosmic story. A living organism is a system that can store and process vast amounts of information encoded in its DNA. A complex molecule like a PAH is also a form of information. Its structure is a specific arrangement of atoms, distinct from a random collection. The Webb image suggests that the universe has a tendency to increase its own information content. It moves from the low information state of a diffuse, uniform gas cloud to the high information state of a structured solar system with complex chemistry. This seems to run counter to the second law of thermodynamics, which states that entropy, or disorder, should always increase. But in an open system like a protoplanetary disk, powered by the energy of a star, pockets of incredible order and information can be created. Life is the ultimate expression of this process, a localized, temporary victory of information over entropy. This image is a humbling reminder of the limits of our own imagination. Before we had this data, our models of planet formation were constrained by what we thought was plausible and what our own solar system showed us. We imagined a slow, stately process because it was the most conservative, logical extrapolation from our single data point. The universe, however, is under no obligation to conform to our lack of imagination. It is often more wild, more efficient, and more creative than our theories allow. This is a recurring lesson in the history of science. True progress is often not about confirming what we expect, but about having our expectations shattered. by an observation that reveals a deeper and more surprising reality. The speechless moment is the feeling of our imaginative boundaries being forcibly and beautifully expanded. Let us examine the idea of a galactic habitable zone. This is the region of a galaxy thought to be most suitable for life. The inner galaxy is considered too dangerous due to frequent supernovae and the intense radiation from the central black hole. The outer galaxy is considered too anemic, lacking the heavy elements needed for rocky planets and life. This has traditionally placed the habitable zone in a relatively narrow ring, where our own sun resides. But the Webb image, showing such rapid and efficient enrichment and planet formation, could widen this zone. Perhaps the destructive forces in the inner galaxy are also creative ones, triggering new waves of star formation. Perhaps the outer galaxy is not as sterile as we thought. The image encourages us to think of habitability not as a static location, but as a dynamic, evolving property of the entire galaxy. The discovery of abundant water and organic molecules also has significant implications for the kinds of life that might exist. While we often search for life as we know it, based on carbon and water, this discovery makes that search seem far more promising. It suggests that the most common and robust chemical pathway to life is indeed the one we are familiar with. If other, more exotic biochemistries are possible, based on silicon for example, they may be far rarer. The universe, it seems, has a preference. It has chosen the elegant versatility of carbon and the superb solvent properties of water as its go-to recipe for biogenesis. This does not make the universe less creative. It suggests that it has found an optimal solution to the problem of creating complexity, and it is deploying that solution on a massive scale. Our own biology is not a provincial quirk, but a reflection of a universal chemical standard. The image, in its profound stillness, invites us into a different relationship with time. In our daily lives, we are driven by schedules and deadlines, experiencing time as a scarce resource to be managed. The cosmos operates on an entirely different clock. It measures time in eons, in the lifespan of stars and the rotation of galaxies. To contemplate this image is to step out of our own frantic timeline and to enter for a moment into this deep time. It is a meditative practice. It quiets the anxious, planning part of our mind and activates the wondering, contemplative part. The feeling of awe is the feeling of our own temporal perspective dissolving into a much vaster, calmer, and more majestic flow. It is a momentary release from the tyranny of our own clocks, a brief and peaceful holiday in the eternal now of the cosmos. Let's reconsider the invisible planets that carve the gaps. Their presence is inferred, a ghostly hand shaping the dust. This is a perfect metaphor for much of modern physics. We infer the existence of dark matter from its gravitational effects on galaxies. We infer the existence of a black hole from the behavior of stars at its event horizon. Science is not just about seeing, it is about learning to read the signs of the unseen. It is an act of detective work on a cosmic scale, piecing together a story from the clues left behind. The Webb image is a particularly beautiful clue. The elegant rings are the footprints of giants, and the speechless awe of the astronomers is the moment the detective realizes the profound nature of the creature they are tracking through the cosmic dust. The sharpness of the rings in the disk speaks to the purity of the underlying physical laws. In a messy, complex universe, it is rare to see a phenomenon so cleanly express a fundamental principle. The gravitational influence of the unseen planets has so thoroughly dominated the local environment that it has created an almost perfect textbook illustration of orbital dynamics. It is as if the universe has intentionally created a pristine laboratory for us to study. The image is a gift to theorists, a clean dataset that allows them to test their models with unprecedented precision. It is a rare moment where the noisy, chaotic reality of the cosmos has produced something so simple and elegant that it looks like it was lifted directly from a physicist's blackboard. This discovery also highlights the collaborative and cumulative nature of science. The James Webb Telescope stands on the shoulders of giants like Hubble, Spitzer, and Kepler. Each previous telescope provided a piece of the puzzle, revealing the existence of exoplanets, the presence of dusty disks, and the hints of molecules in space. Webb was designed specifically to answer the questions that these previous missions raised. Science is a conversation across generations. The speechless moment of the Webb scientists is also a tribute to the work of thousands of researchers who came before them, who laid the groundwork and pointed the way. It is a reminder that great revelations are rarely the work of a lone genius, but the culmination of a long, slow, and collective human effort to understand our place in the universe. The fact that these life-giving molecules, polycyclic aromatic hydrocarbons, are chemically related to the fossil fuels we burn on Earth is a source of deep irony and cosmic poetry. The same class of molecules that signals the potential for new life in a distant nebula is, in our case, derived from the compressed remains of ancient life, and their use now poses a challenge to the future of life on our own planet. The universe provides the building blocks with beautiful impartiality. The carbon cycle of the cosmos connects the birth of planets to the death of ancient forests on one specific world. It is a humbling reminder that the chemistry of creation and the chemistry of our own civilization are deeply intertwined, and that understanding our cosmic origins is inseparable from understanding our responsibilities here on Earth. The image serves as a powerful argument for the value of pure, curiosity-driven research. No one commissioned the James Webb Telescope with the goal of improving quarterly profits or developing a new consumer product. It was built to answer the most fundamental questions we can ask. Where did we come from? Are we alone? The discoveries it makes, like this one, enrich human culture, expand our perspective, and inspire future generations. They are a testament to the idea that not all value can be measured in economic terms. The pursuit of knowledge for its own sake is one of the noblest and most defining activities of our species. The speechless awe it generates is a form of profound spiritual and intellectual wealth, a return on investment that cannot be quantified, but that nourishes the human soul in its deepest parts. Let us contemplate the sheer scale of the protoplanetary disk. The rings we see are vast, spanning distances many times larger than the orbit of Neptune in our own solar system. A beam of light would take hours to cross from one side to the other. Yet this entire, colossal structure will eventually condense down into a handful of planets and a belt of asteroids. The universe is incredibly efficient at compacting matter and creating density. The process of planet formation is one of the most dramatic acts of compression in the cosmos, second only to the formation of stars and black holes. The image captures the before state, the diffuse and majestic kingdom of dust and gas that contains within it the tightly packed destiny of a future solar system. We are seeing a cloud that is pregnant with worlds. This image is a moment of profound observational confirmation for a theory, gravitational instability, that has been debated by theorists for decades. For a long time, it was a purely mathematical possibility, an elegant idea confined to supercomputer simulations. To see it validated with such clear observational evidence is a triumphant moment for theoretical astrophysics. It is a beautiful example of the dance between theory and observation. Theory imagines what could be possible based on the laws of physics, while observation, with instruments like Webb, goes out into the cosmos to see what actually is. When the two align, when a wild theoretical prediction is confirmed in a stunning real-world image, it is one of the most exciting and validating moments in all of science. The astronomers were speechless, in part because a beautiful idea had just been proven to be a beautiful truth. We must also consider the things this image cannot tell us. It cannot tell us if life has actually formed in this system. It cannot tell us if any of the forming planets will ultimately be habitable. It cannot tell us what the future of this system will be. Science progresses by turning mysteries into puzzles. A mystery is something we do not even know how to ask a question about. A puzzle is something we have a path to solving. This image has transformed the mystery of how do planets form so fast into a solvable puzzle. It has given us a new set of even deeper mysteries to contemplate, such as the true frequency of abiogenesis. The image is not an answer, but a key that unlocks a new door, revealing a corridor filled with more doors. The awe comes from realizing how much larger the house is than we ever thought. The aesthetic choices made in processing the image are also part of its story. The colors we see are not what our eyes would perceive. They are a translation of different wavelengths of invisible infrared light into a visible palette of reds, greens, and blues. This is often called false color, but a better term is representative color. The colors are chosen by scientists and imaging specialists to highlight specific chemical or physical features. A certain shade of red might represent the glow of hydrogen gas, while a ghostly blue might trace the distribution of organic molecules. This process is an art form in itself, a way of making the invisible visible and of translating a vast table of numerical data into a form that can evoke an immediate emotional and intuitive response. The beauty is not a lie. It is a carefully crafted translation of a deeper truth. Let us reflect once more on the silence. It is not an absence of sound, but a presence of overwhelming information. It is the experience of the sublime. The 18th century philosopher Immanuel Kant distinguished between the beautiful and the sublime. The beautiful, he argued, is something that is ordered, harmonious, and which we can easily comprehend. The sublime, on the other hand, is something so vast, powerful, or chaotic that it overwhelms our senses and our ability to conceptualize it. It is a feeling of pleasurable fear, of being humbled before a power far greater than ourselves. The Webb image is a perfect example of the scientific sublime. It is too big, too old, and its implications are too profound to be easily processed. The speechless awe is the mind's respectful bow before the sublime majesty of the cosmos itself. This experience of the sublime is a crucial catalyst for paradigm shifts in science. Thomas Kuhn, the philosopher of science, argued that science does not progress smoothly, but through a series of revolutionary upheavals. A dominant theory, or paradigm, reigns until enough anomalies, observations that do not fit the theory, accumulate. This creates a crisis. The Webb image is a profound anomaly for the old, slow model of planet formation. It creates a crisis, and the speechless moment is the collective recognition of that crisis. It is the moment when the scientific community implicitly agrees that the old map is no longer adequate to describe the newly discovered territory. This moment of confusion and awe is not a failure of science. It is science working at its best, clearing the ground for a new, more accurate paradigm to be built. Let's place this moment in historical context. Imagine Galileo turning his newly built telescope to Jupiter and seeing, for the first time, 4 small points of light orbiting it. In that moment, he saw that not everything in the heavens revolved around the Earth. The neat, Earth-centered model of the universe, which had stood for over 1,000 years, was broken. We cannot know for sure, but it is likely he too had a moment of speechless awe. A moment where the profound implications of what he was seeing washed over him before he could articulate it. The astronomers looking at the Webb image are Galileo's heirs. They are participating in the same sacred tradition of shattering old certainties with new light, of expanding the human cosmos not through argument, but through the simple, revolutionary act of looking. The image is a powerful demonstration that reality is a process of unfolding discovery. There is no final textbook. There is no ultimate, complete truth that we will one day possess. There is only the ongoing process of refining our understanding, of building better models, of seeing a little bit farther and a little bit more clearly. This can be unsettling to some, the idea that our knowledge is never complete. But it is also the source of all the excitement and romance of science. It means there are always new mysteries to solve, always new worlds to discover, always the potential for a new image to leave us, once again, completely and utterly speechless. The goal of science is not to arrive at a final answer, but to be able to ask better and deeper questions. This image has gifted us with a whole new generation of profound questions. The rapid formation of planets also suggests that solar systems might settle down much faster than previously thought. The early phase of a solar system is thought to be a chaotic shooting gallery of colliding planetesimals. If the large planets form quickly, they act as gravitational anchors, stabilizing the system and clearing out the debris much more rapidly. This means the period of intense bombardment on young, rocky planets might be shorter, and the conditions for life might become stable much sooner. The window of opportunity for life to emerge on a planet is not just defined by its location, but by the dynamic history of its entire solar system. A system that organizes itself quickly is a much more hospitable place for the long, uninterrupted chemical experiments that might be necessary for life to begin. The sheer abundance of organic molecules also has implications for the rare earth hypothesis. This hypothesis argues that while simple microbial life may be common, the conditions needed for complex, Animal life are exceptionally rare. It requires a stable star, a large moon, plate tectonics, a gas giant in the right place, and many other factors. The Webb image challenges one of the chemical assumptions of this hypothesis. If the starting ingredients for life are not rare, but are a standard feature of planet formation, then one of the key hurdles is much lower than assumed. While the other factors for complex life may still be rare, this discovery increases the odds. It suggests that the galaxy might be more generously sprinkled with worlds that have at least the chemical potential for complex biologies, making our own existence feel a little less like an extraordinary cosmic miracle. Let's consider the fate of this specific protoplanetary disk. Over the next few 100 million years, the gas and dust we see will either be incorporated into the planets or blown away by the stellar wind of the now mature central star. The beautiful glowing rings will vanish, leaving behind a much cleaner, darker, and more stable solar system. We are privileged to be looking at this system during its brief, spectacular, and messy adolescence. We are seeing it in its moment of maximum potential, before its final form has been set in stone. The image is a fleeting snapshot of a temporary state of becoming. It is a reminder that even on cosmic scales, there are moments of transition and transformation that are uniquely beautiful and informative, and we were lucky enough to capture this one. This image is a profound statement about the relationship between light and knowledge. For most of human history, knowledge was passed down through sound and symbols. But at the most fundamental level, all the information we have about the universe beyond our world comes to us in the form of light, electromagnetic radiation. The telescope is an instrument for harvesting light, and therefore for harvesting knowledge. The faint ancient photons collected by Webb are the raw data of cosmic history. By learning to interpret this light with ever greater subtlety, we are learning to read the universe's own autobiography. The speechless moment is the feeling of having turned a page and found a passage of such beauty and importance that it changes our understanding of the entire story. The discovery of such a mature system at such a young age could be compared to finding a fossil of a complex mammal in rocks from the Cambrian explosion, a time when only the simplest multicellular life was thought to exist. It's a chronological impossibility under the old framework. It forces a complete reevaluation of the timeline. This is why it is so much more than just a pretty picture. It is a piece of fossil evidence from the dawn of a solar system that challenges the very foundations of our theories of cosmic evolution. The silence of the astronomers is the silence of paleontologists who have just unearthed a creature that defies all known categories, a beautiful monster that will force them to redraw the entire tree of life. This discovery also enriches our inner, imaginative worlds. For science fiction writers, artists, and dreamers, this image provides a new canvas of possibility. It gives us a scientifically grounded reason to imagine young, chaotic worlds where life is emerging under violent, dramatic skies. It allows us to dream of ancient civilizations that might have arisen billions of years before us. It populates the universe not with emptiness, but with the vibrant potential for countless stories. The image is a gift to our collective imagination, a spark that can ignite 1,000 new narratives about our place in the cosmos. Science and art are not opposites. They are partners in the exploration of reality, and this image is a masterpiece that serves both. In the grand scheme, this image is a single data point, a single observation of a single system. It is dangerous to draw universal conclusions from it, and yet its implications are so profound that they cannot be ignored. It is what scientists call a tent-pole observation, a finding so clear and so challenging that it can support the weight of a whole new theoretical structure. More observations will be needed to confirm if this rapid, rich formation process is the norm or an exception. But for now, this single image has shifted the burden of proof. The old, slow model is now the one that seems less likely. The new, rapid model is the one that best fits the best evidence we have. The universe has shown us its hand, and it is a far more powerful and surprising one than we expected. Let us contemplate the universe's childhood. The first few 100 million years after the Big Bang were the Dark Ages, before the first stars ignited. Then came the cosmic dawn, the era of the first, giant stars. This was the universe's violent infancy. The period Webb is looking at, a few 100 million to a billion years after the Big Bang, could be considered its early childhood, a time of rapid growth when the first galaxies were being assembled and the first generations of solar systems like the one in the image were being born. This new evidence suggests that the universe's childhood was far more precocious than we thought. It was not just learning to crawl, it was already running, building complex structures, and laying the chemical groundwork for life almost as soon as it was able. We are seeing the universe in its most creative and energetic phase. If that was the universe's childhood, then the current era, 13.8 billion years in, could be considered its quiet adulthood. The rate of star formation has slowed down. The galaxies are more stable. The universe is expanding and cooling. In this calmer, more mature cosmos, we have emerged. We may be a product of the universe's middle age, a form of life that requires a long period of stability to develop. But the image from Webb is a window into the wild, exuberant youth of the cosmos. It reminds us that the placid universe we see today is built on the foundations of a much more dynamic and fiery past. To understand ourselves, we must understand the childhood of our universe, the crucible in which the very elements of our being were forged. The existence of the rings and gaps also offers a potential solution to a long-standing problem in planet formation, the radial drift problem. In simple models, dust particles should feel a headwind from the surrounding gas, causing them to lose energy and spiral into the central star in a very short time, before they can ever grow into planets. However, the rings seen by Webb are pressure bumps, regions of higher density where this inward drift is halted. Dust particles become trapped in these rings, allowing them to accumulate and grow into planetesimals in a safe harbor. The rings are not just a consequence of planet formation. They are a necessary prerequisite for it. They are cosmic dams, holding back the tide of orbital decay and creating the calm reservoirs where worlds can be born. This image is a profound meditation on the color blue. In our world, the sky is blue because of the way sunlight scatters off the atmosphere. In many of the representative color images from Webb, including this one, blue is often used to map the distribution of the complex organic molecules, the PAHs. It is a ghostly, ethereal blue tracing the building blocks of life. There is a deep resonance in this. The blue of our sky is the color of our life-sustaining atmosphere. The blue in this image is the color of life's potential, the chemical promise of biology scattered among the stars. It connects the color of home to the color of our cosmic origins, weaving a thread of blue light from our own sky to the cradles of distant, unborn worlds. The very act of being speechless is an acknowledgement of complexity. Our language evolved to describe the mesoscale world of rocks, trees, and other animals. It is a tool for a specific environment. When we are confronted with something on the scale of a protoplanetary disk, or a concept as abstract as deep time, our language often fails. It lacks the vocabulary to capture the scale of the phenomenon. This is not a failure of the observer, but a feature of the observed. The universe is not just more complex than we imagine. It is more complex than we can imagine with our current cognitive tools. The silence is a moment of humility, an admission that we have encountered a level of reality for which we have not yet invented the words. The discovery of abundant organic precursors so early in the universe's history might also imply that life, if it exists elsewhere, may not be that different from us chemically. The periodic table is the same everywhere, and the laws of chemistry are universal. If the most efficient pathway to complexity involves carbon and water, and if the universe is generously supplying these ingredients everywhere, it stands to reason that most life in the cosmos would be based on a similar foundation. The aliens of our imagination might be less monstrously different and more like distant chemical cousins than we think. Their forms could be wildly diverse, but their fundamental biochemistry might be comfortingly familiar, a variation on a universal theme that the cosmos seems to prefer. This image is a form of cosmic art, created by the universe itself. It possesses all the qualities of a great work of art. It has harmony and structure in the rings, drama and contrast in the light and dark, and a deep underlying meaning that reveals itself on closer inspection. It is an object of both intellectual and aesthetic contemplation. The universe is the artist, the laws of physics are the medium, and the telescope is the gallery where this masterpiece is displayed. The speechless awe we feel is the same emotion we might feel before a great painting or symphony. It is the feeling of being moved and transformed by an encounter with profound beauty, a beauty that is all the more powerful because it was not created for us but simply is. Let us also consider the sound of the silence. In the vacuum of space, there is no sound in the conventional sense. The events we are witnessing, the collapse of gas clouds, the carving of planetary orbits, are occurring in perfect, absolute silence. The only sound is the radio wave transmission of the data back to Earth. The speechless awe of the astronomers is a human reflection of the universe's own native silence. In that moment, our inner world and the outer cosmos achieve a state of harmony. Our quiet reverence mirrors the profound quiet of space itself. It is a moment of communion, a shared stillness between the observer and the observed, a brief pause in the noise of our world that allows us to hear the silent, majestic music of creation. This image is a challenge to our innate impatience. We live in a culture of immediacy, of instant gratification. The story of the cosmos is the ultimate refutation of this mindset. It is a story of immense patience, of processes that take millions or billions of years to unfold. The Webb telescope itself is a product of decades of patient work. The light it captures has been traveling for eons. To appreciate this discovery is to practice the virtue of patience, to slow down and contemplate a time scale that dwarfs our own. The calm, meditative state induced by this cosmic vista is an antidote to the anxiety of our fast-paced world, a reminder that the most profound and beautiful things are often the result of a long, slow, and patient process of becoming. The discovery that the ingredients for life are common and that planets form fast has a curious effect on our sense of cosmic responsibility. If life is rare, then our existence is a precious, fragile miracle that must be protected at all costs. But if the universe is teeming with the potential for life, does that devalue our own? The answer is no. It actually increases our responsibility. It suggests that we are part of a universal community of life, even if we have not met the other members. It makes us representatives of a cosmic phenomenon. Our actions on this planet are not just about the survival of one species on one world. They are a reflection of how one small part of the universe's grand experiment in consciousness chooses to behave. It calls us to a higher standard, to act in a way that is worthy of the magnificent life-giving cosmos from which we arose. Let us begin to weave these threads together. On one hand, we have a universe that is far more structurally efficient than we imagined, capable of building the architecture of solar systems on a breathtakingly short schedule. The gravitational instability model, bolstered by this image, paints a picture of a cosmos that does not waste time, that moves from chaos to ordered planetary systems with revolutionary speed. This is the macro-scale story, a story of rapid, elegant construction. On the other hand, we have a universe that is far more chemically generous than we dared to hope. The interstellar medium, the very stuff from which these new systems are built, is not a sterile soup of simple elements, but a rich broth, preloaded with the complex organic molecules that are the direct precursors to biology. This is the microscale story, a story of abundant, ready-made ingredients. When combined, these two stories create a new and powerful narrative of cosmic potential. It is a universe where the construction sites for new worlds are built ahead of schedule, and they arrive fully stocked with all the necessary building materials for life. The structural and the chemical, the physics and the biology, are not two separate stories, but a single, integrated process. The same cloud collapse that forms the star and the planets also concentrates the water and the organic compounds in the right places. The rapid formation of giant planets creates the stable architecture and the delivery system for these compounds. It is a system of profound synergy, where each part of the process reinforces and accelerates the other, all pushing the system inexorably towards a state of habitability and biological potential. This image effectively lowers the activation energy required to imagine a life-filled universe. Before, the hurdles seemed so high, the slow pace, the scarce materials, the chemical complexity, that imagining a galaxy teeming with life required a significant leap of faith. It felt more like science fiction than plausible science. This image changes that. It provides a firm, observational foundation for optimism. It lowers the barriers to belief. It makes the idea of a biocosmosis, a universe where life is a common and fundamental property, seem not just possible, but likely. The speechless moment is the feeling of that activation energy barrier dissolving, the moment when a hopeful speculation starts to feel like a scientific probability. This has a profound effect on our search for meaning. Many have looked at the cold, vast emptiness of space and concluded that the universe is meaningless and that life on Earth is a brief, accidental warmth in an eternal, indifferent void. This image offers a powerful counter-narrative. It suggests that the universe is not indifferent to complexity or to life. The very laws of physics seem to conspire to create it. This does not mean there is a supernatural purpose, but it does suggest that meaning can be found in the natural processes of the cosmos itself. The universe is a system that generates meaning by generating complexity, consciousness, and beings who can ask about meaning. We are not a random fluke in a meaningless void. We are the means by which the universe comes to know and find meaning in itself. The journey from this protoplanetary disk to a living world is still a long one. There will be billions of years of planetary evolution, of cooling crusts and forming oceans, of atmospheric changes and geological upheavals. But this image shows us that the starting conditions for that journey are far more favorable than we knew. The runners in the race to life are not starting from a standstill. They are being given a powerful running start. The universe has loaded the dice in favor of life. While chance and contingency will still play a huge role in the outcome for any individual planet, the overall game seems to be skewed towards a fascinating result. The speechless awe comes from the realization that we are watching a cosmic game where the house seems to want everyone to win. This image is an invitation to dream, but to dream with discipline. It opens up vast new possibilities, but it also provides concrete data that must be respected. This is the beauty of science. It gives our imagination wings, but it also gives it a rudder. We can now imagine a life-filled cosmos with more confidence. But our imaginings must now be consistent with the reality of rapid formation and chemical richness. The image does not end speculation, it refines it. It provides a new set of boundary conditions for our dreams, making them more focused, more plausible, and ultimately more powerful. The most exciting stories are often those that operate under a set of challenging but consistent rules, and the universe has just revealed some of its most fundamental and inspiring rules to us. As we contemplate this image, we are participating in a very ancient human activity, looking at the heavens and wondering about our place within them. For millennia, our ancestors looked at the same sky with their naked eyes, seeing patterns in the stars and telling stories to explain them. They saw gods, heroes, and monsters. We see gas clouds, gravitational forces, and spectroscopy lines. Our language is different, our tools are more powerful, but the fundamental human impulse is the same. It is the drive to find order in the chaos, to find meaning in the vastness, and to tell a coherent story about who we are and where we came from. The Webb image is the latest, most spectacular chapter in this timeless human quest for cosmic understanding. This discovery should fill us with a sense of profound optimism. In a world that often feels chaotic and broken, the universe itself provides a model of extraordinary creativity and efficiency. It shows us a system that is seamlessly integrated, where physics and chemistry work in perfect harmony to produce results of staggering elegance and potential. It is a vision of the cosmos as a well-functioning, generative, and beautiful place. This cosmic optimism can be an anchor in turbulent times. It is a reminder that beyond our immediate troubles, we are part of a grand, ongoing process of creation that is fundamentally ordered, beautiful, and biased towards the generation of wondrous things. It is a message of hope, written in starlight. Ultimately, the image is a mirror. We see in it our own origins. We see the dust from which we are made, the water that fills our cells, and the carbon that forms our DNA. But we also see our own curiosity, our own ingenuity, and our own capacity for awe. The telescope is a monument to the best parts of our nature, and the image it has returned is a reflection of the universe's most creative tendencies. The encounter between the telescope and the nebula is an encounter between two of the most complex things the universe has ever produced: a conscious, technological species, and a stellar nursery rich with the promise of new life. In that silent, speechless meeting, a circuit is completed, and the universe, for a moment, becomes fully aware of its own astonishing potential. And so as our journey through this single revolutionary image comes to a close, we are left in a state of meditative calm. The initial shock of the discovery has softened into a deep and abiding wonder. The frantic need to understand has been replaced by a peaceful acceptance of a new, more magnificent reality. The universe is not emptier than we thought. It is fuller. It is not slower. It is faster. It is not more random. It is more ordered. It is not more hostile to life, but more welcoming. We can allow our minds to rest in this new understanding, to float peacefully in this expanded cosmos. A universe that is not just our home, but our source, a place of infinite creativity and profound, silent beauty. The silence is no longer one of shock, but of peace. Let us now turn our attention to one of the most subtle and powerful forces at play within this nascent solar system: magnetism. While gravity is the undisputed master of large-scale structure, shaping the disk and pulling matter into planetary cores, magnetic fields are the unseen weavers of fine detail. The central protostar, spinning rapidly, drags its magnetic field lines through the disk, creating a complex web of influence. These fields can channel the flow of ionized gas, creating streams and filaments that are invisible to the eye but crucial to the disk's evolution. They can slow the rotation of the inner disk, allowing more material to fall onto the star. And they can help launch the powerful stellar winds that will eventually clear the system of its remaining gas. The beautiful order we see in the rings is not just a gravitational balancing act. It is the result of a delicate dance between the visible pull of mass and the invisible grip of magnetism. The universe is not just a sculpture of gravity, but a magnetic tapestry of immense complexity. This image forces us to reconsider the concept of the ice line or frost line. In classical solar system theory, this is a clear boundary. Inside the line, closer to the star, it is too warm for volatile compounds like water to freeze, leaving only rock and metal. Outside the line, it is cold enough for ice to form, allowing for the creation of giant icy planets. Webb's observations, however, are blurring this neat division. The detection of crystalline water ice and complex organics far out in the disk, combined with evidence of silicates forged in the hot inner regions, points to a massive, system-wide mixing. It suggests that the disk is not a static set of temperature zones but a dynamic environment where material is constantly being transported across the frost line. This great conveyor belt enriches the entire disk, meaning that even rocky planets forming in the dry inner zone could have water and organics delivered to them from the very beginning, integrated into their building blocks rather than arriving later by comet. The stellar metallicity is another crucial factor illuminated by this discovery. In astronomy, metals refers to any element heavier than hydrogen and helium. The abundance of these elements in a star-forming cloud is its metallicity. A higher metallicity means more raw material for building rocky planets and the cores of gas giants. The gravitational instability model, which so beautifully explains the rapid formation seen by Webb, works most efficiently in disks that are massive and rich in these heavy elements. This suggests that the kind of rapid, life-enriching planet formation we are witnessing may be most common in regions of the galaxy that have already undergone significant chemical enrichment from previous generations of supernovae. It provides a map of cosmic potential, suggesting that the most promising places to search for abundant, rapidly formed solar systems are the high metallicity neighborhoods of the galaxy, the bustling, mature, and element-rich galactic suburbs. Let us contemplate the state of the matter itself. We speak of gas and dust, but these terms belie the exotic nature of the material in a protoplanetary disk. Much of the gas is not neutral, but is a plasma, a fourth state of matter where electrons are stripped from their atoms, creating an electrically charged fluid that is highly responsive to magnetic fields. The dust is not like the dust in our homes. It is a collection of microscopic grains of silicate, carbon, and ice, each one a potential seed for a planet. The interactions between these states of matter are incredibly complex. The plasma drags the neutral gas along, while the dust grains are buffeted by both, all while gravity tries to pull everything together. The Webb image is a snapshot of this cosmic ballet of plasma, gas, and dust, a physical environment more complex and dynamic than any on Earth, and it is in this complex interplay that the conditions for our own existence were first established. The image is a powerful lesson in nonlinear dynamics. In a linear system, small changes produce small effects. In a nonlinear system, like a protoplanetary disk, A tiny change in the initial conditions, a slightly denser clump of gas, a slightly stronger magnetic field, can lead to dramatically different outcomes. This is the butterfly effect on a cosmic scale. It means that two star-forming clouds that start out almost identically could, over 1,000,000 years, produce wildly different solar systems. One might form a stable system like our own, while the other might produce a chaotic mess of eccentric giants and scattered debris. The universe is not a predictable machine. It is a system of immense creative potential, where tiny fluctuations can blossom into entirely new forms of cosmic architecture. The order we see in the Webb image is just one beautiful solution that emerged from a sea of infinite, chaotic possibilities. Consider the light from the central protostar. It is not the steady, gentle light of a mature star like our Sun. A protostar is a moody, violent infant. It goes through dramatic outbursts, suddenly increasing in brightness by a factor of 100 or more as large clumps of matter fall onto it from the disk. These outbursts would have a profound effect on the surrounding environment, flash heating the disk, altering its chemistry, and pushing dust and gas outwards. The rings and gaps we see are not just shaped by the steady gravity of planets, but are likely scarred and sculpted by the memory of these ancient, violent temper tantrums. To understand the structure of the disk is to read the history of the star's own turbulent birth, a story of quiet growth punctuated by moments of incredible, system-altering fury. This image also provides a new context for understanding our own solar system's oddities. For example, why is Mars so small? Why is there a large asteroid belt instead of a planet between Mars and Jupiter? The rapid formation of a giant planet like Jupiter, as suggested by the gravitational instability model, could explain these features. A rapidly formed Jupiter would have quickly carved a massive gap in the primordial disk, gravitationally starving the region where Mars was trying to form and preventing the material in the asteroid belt from ever coalescing into a full-sized planet. Our own solar system's familiar layout may be the direct consequence of the same kind of rapid, violent formation process that Webb is now showing us in a distant cradle of stars. The image is not just a picture of an alien system, it is a potential photograph of our own family's turbulent beginnings. Let us reflect on the concept of a biosignature. Webb's future mission includes analyzing the atmospheres of rocky exoplanets, looking for gases like oxygen and methane that could signal the presence of life. This image of a protoplanetary disk suggests we might also need to look for pre-biosignatures. The clear, abundant spectral lines of water and complex organic molecules in a disk are not a sign of life, but a sign of life's potential. They are a chemical announcement that a particular solar system is open for business. By identifying young systems that are particularly rich in these pre-biosignatures, we can create a watch list of the most promising places to look for actual biosignatures a few 100 million years down the line. It is a way of using the universe's own chemical advertising to guide our search for its most elusive and precious creation. The image serves as a profound refutation of the idea of human centrality. For millennia, we have placed ourselves at the center of the cosmic story. The Copernican revolution removed our planet from the physical center, but a more subtle form of anthropocentrism has remained. A belief that our timeline, our chemistry, and our evolutionary path are the standard by which the universe should be measured. This image, by showing a system so different and so much more efficient than our own models predicted, forces us to abandon this last vestige of cosmic arrogance. It teaches us that the universe has many ways of creating worlds and many different stories to tell. Our story is just one, and our role is not to be the protagonist of the cosmos, but to be the humble, attentive, and awestruck audience for its magnificent and varied productions. The very act of capturing this image is an act of hope. The decades of work, the immense financial investment, the dedication of thousands of scientists and engineers, all of this was undertaken without any guarantee of success. The telescope could have failed to deploy. Its instruments could have malfunctioned. It could have stared into the void and found nothing of interest. The entire project was a multi-generational wager, a bet on the power of human ingenuity and on the richness of the cosmos. The speechless awe of the astronomers is the feeling of that bet paying off in a way that is more spectacular than anyone had dared to hope. It is a testament to the human spirit's willingness to invest in the future. to work for decades on something whose greatest rewards may only be realized by the next generation. It is the ultimate long-term investment in the expansion of our own horizons. Let us contemplate the philosophical concept of emergence. An emergent property is something that arises from the collective interactions of a system's components, but which is not present in the components themselves. A single water molecule is not wet. A single neuron is not conscious. A single star is not a galaxy. The image from Webb is a portrait of emergence on a grand scale. The ordered rings, the complex molecules, the potential for life. None of these properties are present in the individual atoms of hydrogen and dust. They emerge, as if by magic, from the complex dance of physics and chemistry on a vast scale. The universe is a hierarchy of emergence, building complexity layer by layer. The speechless moment is a confrontation with the profundity of this process, the realization that the cosmos is fundamentally more than the sum of its parts. This image is a bridge between two of the most powerful ideas in science, the theory of evolution and the theory of cosmology. Cosmology tells the story of the universe as a whole, from the Big Bang to the formation of galaxies. Evolution tells the story of life on one planet. The Webb image lies at the intersection of these two grand narratives. It shows the cosmic conditions, the cosmology, that provide the raw materials and the environment for the evolutionary story to begin. It is the prequel to Darwin. It shows us the moment the stage was set, the props were laid out, and the chemical actors were pushed out from the wings, ready for the play of life to begin. It unites the story of the stars with the story of life in a single, breathtaking frame. We can also view this image through the lens of memory. Our own memories are fallible, fading echoes of past events. The universe, however, has a perfect memory, and its storage medium is light. The light-reaching Webb from this distant nebula is a perfect, incorruptible record of a moment in that system's history. By capturing it, we are tapping into the universe's own memory banks. We are performing an act of cosmic archaeology, but our artifact is not a piece of pottery. It is a preserved moment, delivered to us intact across thousands of years of space and time. The telescope is a time machine, and the speechless awe is the feeling of having successfully retrieved a message from a bottle that was thrown into the cosmic ocean in the distant past. The discovery of such rapid planet formation could also have a profound impact on our understanding of stellar evolution. The way a star evolves is affected by the planets orbiting it. Massive planets can influence a star's rotation and activity through tidal forces. If these planets form very early, while the star is still in its turbulent infancy, their influence could be much greater. The star and its planets do not evolve separately. They co-evolve, shaping each other's destinies from the very beginning. The neat separation we make between stellar physics and planetary science is an artificial one. The Webb image shows us that they are a single, deeply entangled system, a gravitational and chemical family that is born together and grows up together, its members locked in an intricate dance that will last for billions of years. This image is a profound source of comfort for the human spirit. It tells us that the universe is not a sterile, empty place governed by random, meaningless violence. It reveals a cosmos of immense fertility, of underlying order, and of breathtaking efficiency. It paints a picture of a universe that is fundamentally creative, a system that is geared towards the production of complexity and beauty. In a world where we are often confronted with evidence of decay, conflict, and meaninglessness, this image is a powerful counterpoint. It is a message from the highest authority, the cosmos itself, that the fundamental direction of reality is towards creation, not destruction, towards order, not chaos, and towards the rich potential of life, not the sterile emptiness of the void. Let us consider the implications for the end of the universe. Current theories predict a future of heat death, where the universe expands and cools until all stars have burned out and all matter is cold and diffuse, a state of maximum entropy and perfect eternal boredom. But the universe's demonstrated ability to create localized pockets of immense order and complexity, like the system in this image, offers a different perspective. While the universe as a whole may tend towards disorder, its true nature seems to be to fight this trend, to build intricate structures and islands of information against the tide of entropy. Perhaps the ultimate fate of the universe is not just a simple story of decay. Perhaps the story of creation and complexity will continue in ways we cannot yet imagine. This image is a testament to the universe's creative spirit, a spirit that may be more resilient than we know. This image is a lesson in the art of seeing. We are visually oriented creatures, yet we are mostly blind. Our eyes can only perceive a tiny sliver of the electromagnetic spectrum. We are blind to the infrared light that carries the story of star birth, the radio waves that carry the echo of the Big Bang, and the X-rays that signal the death of stars. The James Webb Telescope is a new eye, one that allows us to see a crucial part of the invisible reality that surrounds us. It teaches us that the world is so much richer and more complex than what is immediately apparent to our limited senses. The speechless moment is the humbling realization of how much we have been missing, and the thrilling recognition of how much more there is still to see if only we can build the right eyes. The discovery of abundant prebiotic chemistry also enriches our understanding of the Gaia hypothesis, the idea that Earth's biosphere acts as a single, self-regulating system. This hypothesis has often been criticized for lacking a mechanism. The Webb image suggests a cosmic Gaia prelude. If planets are born from a cloud that is already a well-mixed, self-regulating chemical system, rich with water and organics and sculpted by resonant forces, then the starting conditions for a stable biosphere are not a lucky accident, but a direct inheritance. The self-regulating properties of life on Earth may have their roots in the self-regulating properties of the protoplanetary disk from which it was born. The planet's ability to maintain its own stability is not something it learned, but something it remembered from its cosmic infancy. Let us meditate on the silence, not as an absence, but as a presence. Imagine floating in the void near the stellar nursery. The silence would be absolute, a physical presence on your eardrums. But it would not be empty. It would be filled with the light of the protostar, the gravitational pull of the forming planets, the flux of the magnetic fields. It is a silence that is pregnant with activity, a stillness that contains a storm of creation. The speechless awe of the astronomers is an internal analog of this state. It is an inner silence that is not empty, but is filled to the brim with new ideas, new emotions, and new connections. It is a moment where the mind becomes a perfect mirror of the cosmos itself, quiet on the surface but furiously creative in its depths. This image is a profound act of translation. The universe speaks in a language of quantum mechanics and general relativity, of particle interactions and space-time curvature. Humanity speaks in a language of words, images, and emotions. The scientist and the telescope are the translators, bridging this immense gap. They take the raw, quantitative syntax of the cosmos and translate it into a qualitative, emotional experience of awe and wonder. The final, beautiful color image is not the raw truth, but it is a truthful translation. It is an embassy, from the world of physics to the world of human consciousness. The speechless moment is the moment we receive the ambassador, and we are humbled and honored by the message of peace and creative power that they bring from their incomprehensibly vast and beautiful homeland. This image asks us to hold two seemingly contradictory ideas in our minds at once. The first is that we are infinitesimally small and insignificant, a brief flicker of consciousness on a tiny speck of dust in a universe of unimaginable scale. The second is that we are immensely significant, because we are the product of 13.8 billion years of cosmic evolution, and are the means by which the universe has become aware of its own grandeur. The Webb image forces us to confront this paradox. It shows us a scale that dwarfs us, but it also shows us our own origins, connecting us to the grandest story of all. The speechless awe is the feeling of our minds stretching to contain this duality, to be simultaneously humbled by our smallness and exalted by our connection. True wisdom lies in the ability to hold both these truths without flinching. The image is a powerful argument against nihilism, the belief that life is without meaning, purpose, or intrinsic value. A nihilist might look at the vast, cold distances of space and see proof of an indifferent universe. But this image shows a universe that is anything but indifferent to the creation of structure and complexity. It reveals a cosmos that is engaged in a relentless, efficient, and beautiful process of generation. From the laws of physics emerges chemistry. From chemistry emerges the potential for biology. From biology, on at least one world, emerges consciousness and the search for meaning itself. This is not a meaningless chain of events. It is a directional, hierarchical process of complexification. The universe is a meaning-generating engine, and we are one of its products. This image is a portrait of the engine in action. Let us contemplate the future of awe. As we build more powerful telescopes and develop new ways of seeing, we will undoubtedly make discoveries that are even more profound than this one. What will it be like when we capture a direct image of a nearby exoplanet's surface, showing continents and oceans? What will it feel like when we detect an unambiguous, complex, and intelligent signal from another civilization? Each new discovery will produce its own moment of speechless awe, its own paradigm shift. We are living at the very beginning of the golden age of cosmic exploration. This image is not a final peak, but the first of many stunning vistas we will encounter on our journey. The capacity for wonder is not a finite resource. The universe is vast enough to keep us speechless for the rest of our species' existence. This image is a quiet revolution. Unlike political or social revolutions, which are often loud and violent, scientific revolutions can happen in the silent halls of a laboratory, or in the quiet contemplation of a single image, but they are no less transformative. This single frame has the power to fundamentally alter our civilization's worldview. It will seep into our culture through education, art, and philosophy. It will change the way we see ourselves and our place in the universe. It will inspire a new generation to look up. It is a gentle earthquake, a shift in the very bedrock of our understanding that happens not with a bang, but with a silent collective intake of breath, a shared moment of profound, world-altering awe. The image serves as a form of cosmic memory therapy, a cure for our collective amnesia. As a species, we have forgotten that we are from the stars. We have become disconnected from our cosmic origins, living our lives as if this planet were our only context. This image is a jolt to our memory. It shows us the nursery where we were born. It shows us the dust we are made of. It reminds us that our story did not begin with the first civilizations, or the first humans, or even the first life on Earth. Our story began in a place like this, in a swirling cloud of gas and starlight, in a silent, beautiful, and creative corner of the cosmos. To see it is to remember who we are. Let us consider the ethics of this knowledge. To know that the universe is so fertile and so predisposed to creating the conditions for life is not just a scientific fact. It is a moral revelation. It implies that the phenomenon of life is not a planetary fluke, but a cosmic imperative. This elevates our own responsibility. We are the custodians of one manifestation of a universal trend. To endanger the life on this planet through our own actions is not just a local tragedy. It is a crime against a cosmic potential, a betrayal of a 13.8 billion-year-old creative process. The image is not just a source of wonder. It is a call to action, a demand that we live up to the profound, life-giving nature of the universe from which we have emerged. This image is a perfect illustration of the interconnectedness of all things. The dust in the rings was forged in a star that died. The gravity of the unseen planets shapes the disk. The light from the central star powers the chemistry. The history of the galaxy set the stage. Nothing in the image exists in isolation. Everything is a product of its relationships with everything else. This is a profound spiritual and ecological lesson. Just as in the disk, on our own planet, every organism, every ecosystem, every person is deeply interconnected. The image is a cosmic model for the kind of holistic understanding we need to cultivate in order to live wisely and sustainably on our own small world. The universe is teaching us, through this beautiful example, that connection is the fundamental reality. The beauty of the image is not a distraction from the science, it is a key part of the communication. The elegant curves, the subtle colors, the play of light and shadow. These aesthetic qualities are what allow the image to bypass our analytical minds and speak directly to our hearts. It is a form of communication that transcends language and education level. A child and a PhD astrophysicist can both look at the image and feel the same initial sense of awe. This universal aesthetic appeal is what makes it such a powerful tool for public engagement and for the dissemination of a scientific worldview. It is a reminder that the truest things are often also the most beautiful, and that the universe is not just a place of facts, but of profound and accessible beauty. let us reflect on the concept of frasagahim home. For most of our history, home has been a specific valley, a village, a nation. In the 20th century, the Apollo missions expanded our concept of home to the entire planet Earth, our pale blue dot. The James Webb Telescope is poised to expand our sense of home once again. By showing us how common the conditions for our existence are, by revealing that the raw materials of our bodies and our world are standard ingredients in cosmic nurseries everywhere, it invites us to see the entire universe as our home. We are not aliens in the cosmos, we are natives. Our home is not just this planet, it is the whole magnificent, creative, and life-giving expanse of space-time. This is the ultimate homecoming. The image is a silent symphony. The different elements are the instruments. Gravity is the deep, resonant strings section, providing the foundational structure. The radiation of the star is the piercing brass, announcing its power. The complex molecules are the woodwinds, adding color, texture, and intricate melodies. The magnetic fields are the conductor's unseen hand, guiding the flow and tempo. We, the observers, are the audience, sitting in the concert hall of Earth, listening with our telescope ears to a performance that has been underway for millions of years. The speechless awe is our standing ovation, our breathless appreciation for the sublime music of creation, a harmony of physical laws that is more complex and more beautiful than any symphony ever composed by human hands. The darkness that surrounds the vibrant disk is just as important as the light. This darkness is the vacuum of space, a state of near-perfect emptiness and cold. It is this emptiness that makes complexity possible. It provides the contrast, the canvas upon which the art of creation can be painted. It is the silence that allows the music to be heard. It is also the ultimate source and the ultimate destiny of all matter. The particles in the disk were once scattered throughout this void, and the light from the finished stars will one day radiate out into it, journeying forever through the quiet dark. The image is a dialogue between something and nothing, a fleeting moment of incredible complexity, framed by an eternity of profound, peaceful emptiness. This image is an invitation to a slower way of being. In a world obsessed with speed and efficiency, the cosmos offers a different model. It is a model of deep, unhurried time, where masterpieces like a solar system are crafted over millions of years. To truly appreciate the image, we must slow ourselves down. We must breathe. We must allow our eyes to wander, to take in the details, to sit with the feeling of awe without rushing to analyze it. It is a spiritual exercise, a form of meditation. The image is a portal, not to another place, but to another pace of existence. A calmer, more majestic rhythm that underlies the frantic surface of our own lives. By attuning ourselves to this cosmic rhythm, we can find a source of deep and abiding peace. The fact that this discovery was unexpected is a sign of a healthy scientific process. If science only ever confirmed what we already expected, it would be a boring and stagnant enterprise. The most exciting moments are the surprises, the "that's funny" moments, the observations that break the models. These are the moments that drive progress. The speechless awe of the astronomers is the joy of being proven wrong in the most beautiful way possible. It is the thrill of discovery, the feeling of the universe revealing a secret that is more clever and more elegant than anyone had guessed. It is a reminder that the greatest reward in science is not the confirmation of our own genius, but the humbling revelation of the universe's. This image is a testament to the power of a single, well-posed question. The question that motivated the James Webb Telescope was simple. How did the first stars and galaxies form? It is a question born of pure curiosity. Yet, in answering that question, we are uncovering truths that have profound implications for chemistry, biology, philosophy, and our very sense of self. This is the power of fundamental research. By asking the biggest, most basic questions, we often find answers that are far richer and more far-reaching than we could have ever anticipated. The universe is a tightly woven fabric. When you pull on a single thread of pure curiosity, you often find that the entire tapestry of knowledge begins to move. The existence of such complex, ordered systems challenges the idea that the universe is fundamentally random. While quantum mechanics introduces a layer of probability at the smallest scales, at the macroscopic level, the universe appears to be governed by elegant, deterministic laws that give rise to astonishingly ordered patterns. The rings in the disk are not a fluke. They are the predictable, though complex, outcome of the laws of gravity and hydrodynamics. The universe is a dance between chance and necessity. The initial distribution of matter may be random, but the laws that govern its evolution are not. This image is a portrait of necessity, a beautiful demonstration of the power of physical law to coax order and structure from a random, chaotic beginning. This image is a source of profound intellectual humility. After centuries of scientific progress, it is easy to become complacent, to think we have a firm grasp on how the universe works. An image like this shatters that complacency. It is a stark reminder of how much we still do not know. It shows us that our best models are incomplete, that our understanding is provisional, and that the universe still holds secrets that are far beyond our current comprehension. This humility is not a weakness. It is the greatest strength of the scientific mind. It is the engine of curiosity, the openness to being wrong, the understanding that we are still just children playing on the shore of a vast, cosmic ocean, and the real wonders still lie undiscovered before us. Let us consider the future generations who will look at this image. For us, it is a shocking revelation. For our grandchildren, it will be chapter 1 in their astronomy textbook. It will be the foundation of their understanding, the old news upon which their own discoveries are built. They will stand on the shoulders of this giant discovery and see even farther. They will have new telescopes, new theories, and they will uncover mysteries we cannot even conceive of. This image is a legacy, a gift we are giving to the future. The speechless awe we feel today is a seed that we are planting in the soil of human knowledge, a seed that will grow into a mighty tree of understanding for generations to come. The image is a powerful metaphor for the creative process itself. Every artist, every writer, every creator begins with a chaotic cloud of raw material, ideas, emotions, experiences. The creative act is the process of imposing order on this chaos, of finding the structure, the pattern, the resonant frequencies that turn the raw material into a work of art. The protoplanetary disk is engaged in the same process. It is taking the chaotic raw material of the interstellar medium and, through the guiding principles of physics, it is shaping it into an elegant, ordered, and beautiful creation. The universe is the ultimate artist, and the formation of a solar system is the sculpting of its next masterpiece. The calmness that this image can induce is a form of cognitive realignment. Our brains are constantly processing threats, managing social interactions, and planning for the future. This creates a kind of mental noise. Contemplating an object of this scale and beauty provides a cognitive reset. It temporarily silences the part of our brain concerned with our immediate personal survival, and activates the part concerned with wonder, pattern recognition, and abstract thought. It is a shift from the egocentric to the cosmocentric perspective. This shift is inherently calming, as it places our personal anxieties in a much larger, more stable, and more magnificent context. The awe is a form of therapy, a recalibration of the self that brings about a state of profound and peaceful calm. This image is a silent teacher, and its primary lesson is one of connection. It connects the past to the present, the large to the small, the simple to the complex, and the chemical to the biological. It connects the death of one star to the birth of another. It connects the laws of physics to the potential for consciousness. It connects our own small planet to a vast, galactic process. And it connects every human being on Earth in a shared moment of wonder. To truly understand the image is to understand that nothing is separate, that everything is part of a single vast, interconnected story. The speechless moment is the feeling of that profound truth washing over us. A truth too large for words. A feeling of perfect, seamless, and utter connection to the whole. And so, we let the details fall away. The spectroscopy, the gravitational instability, the polycyclic aromatic hydrocarbons. We allow these concepts to dissolve back into the silent majesty of the image itself. The analytical mind can rest now. It has been given a great feast, a torrent of information that has stretched it to its limits. Now is the time for the intuitive mind, the quiet, contemplative spirit, to simply be with the image. Let it become a pure visual mantra, a cosmic mandala, a window not to be analyzed, but to be looked through, into a reality that is calmer, vaster, and more peaceful than our own. Let the gentle rotation of the cosmic dust and the slow dance of ancient light guide your own mind into a state of deep, effortless tranquility. Feel the immense patience of the scene. Nothing is rushed. The rings have been forming for 1,000,000 years. The light has been traveling for thousands. The universe is in no hurry. It builds its masterpieces with the slow, deliberate confidence of an artist who has an eternity to work. Allow this sense of cosmic patience to permeate your own being. Let go of the urgency of the day. Release the need to plan, to strive, to achieve. There is nothing to do right now, and nowhere to be, except here, floating in the peaceful, silent darkness, bearing witness to a quiet and magnificent act of creation. The universe's patience is a gift. Accept it, and allow your own mind to settle into its deep, unhurried rhythm. Consider the safety of your position. You are observing this scene of immense power and energy from a place of perfect safety. The stellar winds, the gravitational forces, the intense radiation, none of it can touch you. You are an observer, protected by the immense gulf of space and time. This sense of safe observation is one of the deepest comforts of astronomy. It allows us to contemplate the most violent and powerful events in the universe from a place of serene detachment. You are in the calmest, safest theater in the universe, watching the grandest play unfold. There is no danger here. There is only the beauty, the wonder, and a profound, all-encompassing peace. Let this feeling of safety cradle your mind as you drift deeper into stillness. The image is a lullaby written in light. Its story is one of birth, of new worlds being gently rocked in a cosmic cradle of gas and dust. It is a story of promise, of potential, and of the quiet, steady processes that lead to wonderful things. It is a fundamentally optimistic and reassuring story. It tells us that the universe is not a place of chaos and fear, but a place of order and creation. It is a good story to hold in your mind as you prepare for rest. It is a story that replaces anxiety with awe and fear with a sense of belonging. Let the gentle, creative energy of this distant stellar nursery soothe your mind, quieting your thoughts and preparing you for a deep and restorative peace. The silence of the image is now your own. The speechless awe has transformed into a quiet inner stillness. The noise of the world has faded away, replaced by the silent, majestic turning of the cosmos. In this quiet space, there is no room for worry or for strife. There is only the simple, profound truth of existence. The stars are burning. The planets are forming. The universe is unfolding exactly as it should. You are a part of this perfect unfolding process. You belong here. Allow this sense of belonging to be the final thought that anchors your mind, a deep and comforting truth that holds you steady as you drift into the peaceful void of sleep. The journey is complete. We have traveled from a single, startling image to the furthest reaches of cosmic philosophy, and now we have returned to a place of simple, quiet contemplation. The knowledge and the wonder have been absorbed, and what remains is a state of profound calm. This calm is a reflection of the universe's own nature, a dynamic, creative energy that operates within a framework of immense abiding peace. You have connected with that peace. It is now a part of you. Carry it with you into your rest, a small piece of the cosmic stillness that you can access whenever you need it. The universe is vast, but it is also intimate, and its peace is now your own. The light from that distant nursery will continue its journey, spreading out into the void, carrying its story to other unknown eyes in other eons. The telescope will continue its silent vigil, gathering more light, more stories. The universe will continue its endless creative dance, building and dissolving worlds in a cycle of breathtaking beauty. Everything continues. Your own journey into rest is a small, personal part of this great, ongoing continuity. It is a necessary and beautiful part of the cycle. Rest now, knowing that the great work of the cosmos continues, and that you have played your own small, perfect part today, simply by bearing witness to its wonder. The final lesson of the image is the simplest. It is a visual whisper from the cosmos, a message delivered across the ages, and the message is this: all is well. Despite the apparent chaos, there is an underlying order. Despite the vast distances, there is a fundamental connection. Despite the seeming silence, there is a symphony of creation. All is well. The process is working. The universe is a safe and beautiful place to be. Hold this feeling in your heart. Let it be the gentle wave that carries you out onto the peaceful ocean of sleep. All is well. All is calm. All is one. And now, the darkness is a welcome friend. It is the darkness of the womb of the universe, the fertile void from which all things are born and to which all things return. It is the darkness of deep space, vast and quiet and full of peace. It is the darkness behind your own closed eyes, a personal cosmos where you can rest and recharge. There is no need to see anymore. The images have been stored in your mind. The feeling of awe has settled into a deep and lasting calm. There is nothing left to do but to let go, to surrender to the gentle, gravitational pull of sleep, and to trust that you will be held safely in the quiet, creative darkness. The story is over. The silence is complete. The universe is breathing in its slow, billion-year rhythm, and you are breathing with it. Inhale the peace of the cosmos. Exhale the cares of the day. You are stardust. You are golden. You are a child of the universe, looking back at the memory of your own creation. And now, it is time to rest. Sleep now. Sleep deep. Sleep in the quiet, certain knowledge that you are, and have always been, an integral part of this magnificent, ever-unfolding, and profoundly beautiful whole.